Welcome to the Linux Academy Nginx Deep Dive. I'm really excited that you've decided to take this course. This is a deep dive course, so we're going to cover both conceptual and hands-on ideas related to Nginx being used as a web server, reverse proxy, and load balancer. We're going to cover some in-depth best practices and common use cases along the way, and by the time you're finished with this, you should feel comfortable configuring Nginx in just about any common use case outside of using it as a mail server. You will become familiar with the Nginx documentation so that you can answer questions that you might run into as you're going along, because the entire topic of Nginx couldn't possibly be covered in one course because it's expandable using modules. So you'll even learn about some of those modules along the way. This course is fitting for anybody who's already proficient working with Linux systems. I'm not going to slow down in order to really talk about some of the command line things that we're doing, but having any sort of experience with a web server isn't required, and that shouldn't scare you away from taking this course. I hope you're ready to learn about Nginx. Hi, my name is Keith Thompson. I'm going to be your instructor for this course. Before we get started, I want you to know a little bit more about me so that it can help you relate to how I cover each of the subjects that we're going to go over. Over the last decade, I've spent thousands of hours developing and deploying Linux systems. I like to think of myself as a software craftsman, and quality is something that's really important to me. And to improve the quality of the things that I build, I'm constantly learning and discovering new techniques and covering new technologies. This passion of technology has only really ever been overshadowed by me in the way that I love to teach. Nothing is more satisfying than seeing somebody learn a new skill that they can apply and grow in some way that they want to in their life. When I'm not covering new technologies or writing code, you'll probably find me reading a book, playing drums or violin, or trying to find somebody to play me in table tennis. But that's enough about me. Time to get into this course, and I hope you're ready to learn something.
Welcome back to the Linux Academy Nginx Deep Dive. Before we get going too far in this course, I want you to be aware of all the tools that you have at your disposal when you're going through this course and really going through any Linux Academy course. If you scroll a little further down on any course page, you'll see the course features that they have, and each of these is clickable and is a video that you can watch that will explain what this feature is if you need a refresher later on. For this particular course, we're going to be utilizing labs, flashcards, cloud servers extensively. It's part of a learning path. You have access to the community, and there are some downloads that you can use. But one I want to draw your attention to is going to be the course scheduler, and this is something that you can utilize by clicking right here. And this will take you to a page that allows you to define when you would like to start, how often you can practice. I can maybe only go through and learn some things on the weekends. And then it will build a schedule for you and break down which videos you should watch on what days based on their length, and also what activities you should engage in. And then you can have it set to do some reminders for you. Besides the course scheduler, you're going to have access to quite a few things on the top navigation of any course, and that's going to be the downloads, which clicking this link will present you with a page that allows you to download any of the attached documents that come with the course. In this case, there are some slideshows that have PDF exports for you. Flashcards, which will let you actually go through and create your own deck to practice things with, or you can work off of the instructor's deck. And if you view the instructor's deck, you can actually take what you've got here and you can customize things by clicking this to fork the card. I'm going to make a small modification just to add a space here and save. Now if I close this, I can see that I have one card in my own deck because I took it from another deck that I thought had useful information in it. The remaining things I want to draw your attention to are going to all be in this community dropdown. Interacting with students will take you over to the community where you can post public posts, that whether that be questions or actually just some thoughts that you might have had about course content. Additionally, you can contact the instructor or site support by clicking this, and then specifically, you'll probably want to click account billing, technical issues, or ask an instructor a private question. And this will be something if you're running into a problem with a course or if you need help with something that's specific that you're working on. Most of the time, I would suggest to you to rely on the community for that, because the instructors, myself included, tend to answer questions in the community daily. We go in there multiple times a day. We love interacting with the community, but that way, if you run into a problem, it's probably a problem somebody else is going to also run into, and you can help others in that way. One more thing I want to draw your attention to, and you'll find this on almost every piece of content throughout the course, is going to be our rating system. And you can rate the course, you can rate videos, you can rate individual quiz questions. And every time you do this, it really does help us out. If you find a piece of content that you think is good, then go ahead and give it a thumbs up. If you think that there's something that we can do to improve, then go ahead and give it a thumbs down and tell us what you think we can do to improve it. That constructive advice really does go into the process of us constantly improving the content that we create on Linux Academy with your help. So I hope this overview of all of the tools that you have at your disposal when going through a Linux Academy course helped out, and now you're ready to move on into the course's content. Welcome back to the Linux Academy Nginx Deep Dive. Before we get digging into demonstrations and really getting our hands dirty with Nginx, we want to cover a little bit of the history and background and some of the things you might not know about Nginx. So related to the history of it, it's not an incredibly old project. It's existed since 2004 when it was actually open sourced by its creator, Igor Sisoev. And it was written to solve a single problem, and that is the C10K problem, which stands for 10,000 concurrent connections. He was trying to build a web server that could handle a lot of stress because he was running into issues when he was using other web servers. So that's the sole problem that was set out to be solved when working with Nginx. And we're going to find out that Nginx does a pretty good job of that based on how it's architected. After open sourcing it, a community started to form around it, and in order to continue developing that, a commercial wing was kind of created, and that's Nginx Inc., and they offer their commercial product, which is Nginx Plus. This course is not going to cover Nginx Plus. We will briefly take a look at some of the differences and the bonus features that you would get if you had a license for Nginx Plus, and occasionally we will run into things in the documentation that look like they would be really cool to use, except for they're only part of the commercial product. Some other things I want to talk about is the fact that it's a high-performance web server. Odds are you probably know that if you're coming to this course. This is one of the main things that really brings people to Nginx, is they're really excited about how performant it is. And something that you might not know, though, is that of the top 1,000 websites on the internet, 50% of them use Nginx. So there are few pieces of software that are quite as battle-tested as Nginx, and you'll see that it can do a lot, and the configuration is relatively simple, and I think that's one of the reasons, besides just the performance, that it was adopted so well. People utilize it as a reverse proxy a lot, and you can do this for SSL TLS termination so that your backend applications don't necessarily need to worry about handling all of the SSL handshakes and that. But then you can also use Nginx for caching content and doing compression of content so that you can send fewer bytes over the wire to your actual end client. And the last big use case that we're going to talk about is going to be using it as a load balancer, and this comes hand in hand with reverse proxy. You'll never really use load balancing without it being a reverse proxy of some kind. But working as a load balancer, you can take requests for a specific server or domain, and you can route those to the proper backend server based on however you decide to, whether that be a round-robin approach or sending it to the server that is currently facing the least amount of load. So these are some of the use cases we're going to go through throughout the course of this video, but I wanted you to have a little bit of a background of Nginx before we got started. Welcome back to the Linux Academy Nginx Deep Dive. We're going to talk about HTTP for the moment because this is going to be the main protocol that's going to be used throughout our time working with Nginx, and I want everybody to have a little bit of a background as to what HTTP is and kind of how it works before we get started. So HTTP stands for Hypertext Transfer Protocol, and it's really the language of the internet. It's what we sort of run into anytime we're making web requests in our browser. You utilize it with something like curl, but it's the application layer protocol built on top of TCP/IP. So TCP/IP is going to be the transport level protocol. So that's going to be how we're shipping packets and data over the internet. And then we're going to utilize HTTP to kind of tell the server or service on the other side of a request what we want it to do. So this is the language that two programs are going to speak to each other to kind of display their intent, if you will. And as a protocol, HTTP defines how that information gets sent over. That way, you can implement servers for it and you can implement clients for it. HTTPS, on the other hand, is Hypertext Transfer Protocol Secure, and this is really just HTTP with another layer in there for TLS and SSL. TLS being the modern version that we utilize, SSL being the precursor for TLS. And this is where you get HTTPS and the green lock in your browser. And how do you know that the content that you're working with is going to be encrypted when speaking between the client and the server? One of the main ways that we interact with HTTP is by utilizing a URL. And if you've never broken down a URL into its components, we can kind of do that now. But the first part is going to be the protocol that you're speaking. So when you see http:// you know that we're speaking HTTP. And if we wanted this to use encryption, we would use HTTPS because it's a separate protocol that can also handle the TLS SSL layer. After that, we're going to have your host name, which is going to be either a domain or an IP address. And then there can be an optional port. And if the port's not there, it's going to assume a default port based on whatever the protocol is. So the default port for HTTP is going to be 80. HTTPS is going to use 443. If you were using something completely different and you were speaking, say, to a Postgres server, you could use the Postgres protocol and it would have its own default port. And then after the port, you're going to run into the path and the file name. So everything up to the last section of that is going to be the path, and then the final bit, in this case the 1, would be the name of the resource. So that would be the file name. And if you're just working with static content, this is going to be based on whatever the server's root is. So the virtual host's root location, it'll be relative to that. And we'll see this throughout the course as we put things into /var/www/name of our website. Anytime you were to request the name of your website domain, then it would give you the path relative to that exact folder in our server. In terms of actually looking at what HTTP is as a protocol, we don't normally see it in this format, but if you want to dump this out of curl, you can actually see what's going on here. But you're going to have a verb, a destination, and the actual type that you're using there. So the protocol, get in this case, is going to be the method or verb that we're working with. And then our URI, which is going to be the path portion of what we had in our URL. After the first line of the request, we're going to see a lot of things that are kind of key value pairs in a way, but it's going to be something on the left-hand side of a colon. That's going to be the header name. And then there's going to be a colon. And then everything on the right-hand side of that is going to be the header value. So in this case, we have a host header that is going to blog.example.com. And this was me manually setting a header using curl, even though I was going to the IP address of 127.0.0.1. And then the user agent was curl. That was the tool that I was using. And then it has an accepted header, which means it can accept any content type back. And there's one thing that you can't see here, and that is the last part of the request is going to be a blank line because you put individual headers on their own lines. And then to signify that you're done with the request, you would have a blank line at the very end. So this is what I sent off to a server. And the response that I get back looks like this, including the headers up top. So these are response headers. And that's going with the protocol, and then a status, which is 200 OK. And then we have our headers being server, Nginx with a version number, the date, content type. And some of these are going to go in and actually be custom headers that we added, like the X powered by, saying that it's utilizing PHP on the back end. And then there's going to be a blank line, and then you'll see the actual body of the response. So this is where if you make a request for an HTML page, you get the HTML page, but you also got all these headers, which gave you this information. So this is really how the browsers that we utilize on websites that we go to, this is how they speak. They speak over HTTP, starting with the URL, going into an HTTP request, and then eventually getting an HTTP response back. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to address one of the common questions that you kind of run into when you're looking at a web server to use, and that is Nginx versus Apache. Apache has been around for a very long time, and it is used on a lot of very high-profile sites. So how do you know which one is which, and what are they going to do a little bit better? We're going to go through some points here and see how Nginx does it versus how Apache does it, how they kind of relate. And what you're going to find is that they're overall pretty simple. When it comes to configuration, Nginx uses its own custom configuration language that is directive-based. And when I say directive-based, it's really you have a keyword, and then that keyword has some arguments. So it works very much like a function. Apache works in the same way. It is also a directive-based language. you're going to have slightly different things to break up your contexts of things. So if you have blocks of configuration in Apache, they go into what kind of looks like XML tags. And in Nginx, you're going to use squiggly braces in order to separate those. But the overall configuration is relatively similar. Nginx comes with one processing method. And remember, it was built to solve a very specific problem, and that was handling a lot of concurrent requests. So that's the only way it knows how to process requests, is in a way that could support a lot of concurrent ones. Apache, on the other hand, has been around for a very long time, and it has multiple processing methods that you can choose from. Prefork being the original one. There's a worker method that spins up separate processes and threads. And then there's an event method, which basically works like worker, except for it is utilized more for keep alive connections. Nginx, on the other hand, uses a worker process model, but then it has threads that go off and actually handle things, but they're only ever triggered by events. So that allows it to work in a very asynchronous way, which is one of the things that helps Nginx get its massive amount of concurrent performance. Both Nginx and Apache can be extended using third-party modules that can be dynamic. And when we say dynamic, I mean that you don't have to recompile Nginx or Apache in order to use them. These have existed in Apache forever, but Nginx, they're a relatively recent addition, and we're going to use a few of these as we go through this course. When it comes to dynamic content, or acting as a reverse proxy to some backend servers, Nginx and Apache have roughly the same performance in terms of actually how fast a single request is going to be resolved. When we're not working with dynamic content, we will be working with static files, and this is actually an area where you're going to find a distinct difference between the two of them. And with that, Nginx is very, very performant when it comes to serving static files. This is one of the things that also makes it really good as a cache. It's comfortable serving static files, and if you can tell it some dynamic content to make it static essentially in a cache, then you can get a lot of performance gains there. Apache is just slower when they're benchmarked side by side serving the same static content. So if you do have a heavily static site, then I would definitely recommend Nginx over Apache. One thing to consider is that Nginx has no concept of an htaccess file if you're familiar with Apache. If you're not familiar with Apache, an htaccess file is a file that you can use to specify configuration based on a subdirectory rather than having global configuration for how things can be accessed. And when you look at this list, you can see that overall they're about the same. They can do a lot of the same things. And it's really in the details and kind of the underpinnings that you're going to find the differences. And when it comes to getting the most out of hardware, Nginx is going to be the best one for the job in that case. It's very performant on lower end hardware because it's just a very lightweight tool. It needs fewer resources in order to get things done. And its processing model is one of the reasons that it is so performant in that way. So that's going to be probably the biggest difference that we're going to run into between Nginx and Apache, but I did want to cover these so you can see that at the end of the day, they're both web servers. They can both work as load balancers and reverse proxies, and they have very similar feature sets. But I happen to think that the configuration language for Nginx is quite a bit easier to read, so I just prefer that. And overall, it's a lightweight tool. Welcome back to the Linux Academy Nginx Deep Dive. In this last video, before we start working with Nginx and getting it installed and starting to configure things, we're going to cover the differences between Nginx and Nginx Plus. And we're going to come up against these a few times throughout this course for sure, but a lot of people sort of wonder what the difference is. So thankfully, they actually themselves have provided a feature matrix for us so we can see what's missing from the open source version of Nginx versus Nginx Plus. And when it comes to a lot of the standard features, which is going to be using it as a reverse proxy, everything related to HTTP here, you're going to find that that's all very much included in the open source version. This is why the open source version of Nginx is so awesome. It has a lot of really awesome features right out of the box. As we continue to move on into different things, you'll see that load balancing, when it comes to that, Nginx Plus adds additional features that we don't have access to when it comes to the open source version. But load balancing at its core is really about just routing traffic to different versions of the same application and then making some modifications to those. So as we go through load balancing later in the course, you might find that we run into a situation where it just doesn't meet your needs, and that might be something where you would consider going with an Nginx Plus license because of some of the extra things that you'll get out of it. But even with this single check mark that we get here, you'll find that this is pretty beneficial to us, and it is a really powerful feature of the server. There's quite a bit of security stuff going on here that you can see, but some of the extra things include JWT authentication, so it'll generate some JavaScript tokens for you if you want. But you'll see that ModSecurity 3.0 web application firewall is in here at an additional cost. But you'll notice that in this course, we actually install this firewall and get it configured. So this is one of the things to sort of realize about Nginx Plus, is it's there both because they have some proprietary features that they don't ship out in the open source version, but additionally, they just take away some of the headache involved if you want to extend Nginx using what's already out there in the open, because sometimes it is kind of tedious. And when we go through and we work with ModSecurity and we get that installed, we'll find that it actually takes quite a while to compile. And if you don't compile it exactly correctly, you'll run into issues also. So that is one thing to consider, is that Nginx Plus can take away some of the potential headaches that you might run into if you're going to be extending Nginx on your own. But that doesn't mean that you can't get the features of Nginx Plus in the open source version just by going out and adding a little bit more in terms of some extra modules. High availability and clustering is one thing that is completely left out from the open source version of Nginx. There are many alternative ways that you would go about doing some high availability things when it comes to using Nginx, and it's probably going to involve you using Nginx as a piece of a larger architecture. But another area where you're going to find that it's kind of lacking is going to be in media delivery. So if you're doing a lot of live streaming and you need to broadcast that yourself, that is something that you're not going to find in the open source version of Nginx. And then there are some additional administrative things that you're going to find, specifically live activity monitoring. We're going to see some passive monitoring and passive health checks using load balancers later on, but there's an actual live activity monitoring dashboard that you can utilize. And the kind of more important feature here is on-the-fly reconfiguration of the load balancer. So there's an API that you can utilize to reconfigure the load balancer without needing to reload any configuration, which that is a very powerful feature. That is probably the one feature that I'm really jealous isn't in the open source version. As we went through this list, and I encourage you to go through this list on your own, you'll see that most of the core features that you're going to want are going to be part of the open source version of Nginx, and you will have a very specific use case if you need to utilize Nginx, and you'll know if that's you, but this isn't something we're going to run into throughout this course. We're not going to utilize Nginx Plus, and there are only a few occasions where we're going to run into something in the documentation that hints at a feature of Nginx Plus that we wish we really had. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to get started with digging into Nginx by taking our obvious first step, and that's we need to have a server set up that is running Nginx. This video is going to utilize the Linux Academy cloud servers that you have access to, and we're going to set up Nginx on a CentOS 7 machine from scratch. If you're more interested in using a Debian-based system like Debian or Ubuntu, there's going to be a separate video after this one that's going to go through the same process on that system, but every video after these two installation videos, I'm going to be using a CentOS server. So there will be differences between what you're doing and what I'm doing, but they should be pretty minor and unrelated to Nginx in the end. So if that is you, then I encourage you to mark this video as complete and move on. But if you want to follow along exactly for the rest of this course, then go ahead and follow along with this video. Our first step is going to be to click on cloud servers and come in here, and we want to create a server, and CentOS 7 is the default. So we should be good to just let that go. This will take a little while in order for it to finish, but then when it's done, we'll have our public and private IP, and we're actually going to utilize the web terminal in order to interact with this server. Once the server is up and running, you should see a login button here. We're going to click this, and it's going to open up a web terminal for us. You might see it isn't running page that'll tell you to wait and refresh it, and if that's the case, you'll just have to wait a few moments for the DNS to propagate and everything to be running. From this page, we are going to sign in using user as our login and the password of 123456, and then we have to enter that password again, and then we're allowed to put in our new password that we're going to use for the remainder of the course on this server. Now we're signed in as the standard user, and this user is a sudo user, so we have access to sudo, and we can do things that require enhanced privileges. And for a lot of this course, we're actually going to just switch over to be the root user because we would have to use sudo for nearly every command that we want to run. But The first thing that we're going to do is we're going to set up a new yum repo so that we can install the official compiled Nginx version from Nginx itself. And if you want to follow along with some of these instructions, you can go over to nginx.org, which is going to be where you're going to find the documentation for Nginx. And this is going to be really, really important for us throughout this course. We're going to look at the documentation a lot. But there is a /n for English /linux_packages.html. And this will show us how we need to go about doing this. And for the pre-built packages for the stable version, which is what we're going to do, we are going to copy this. And then we're going to put this into an etc yum.reposd nginx.repo. So to do that, we're going to use sudo, and then I like to use vim. So I'm going to use vim etc yum.repos.d/nginx.repo. Then I have to enter my password since I'm using sudo. And now from in here, I'm going to set paste, and I'm going to paste that right in there. And this isn't quite right. There are some placeholder values in here. The first one being OS. This needs to change to CentOS. And then the next one being OS release, which in our case is going to be 7. Then we can save this and quit using :qw. Now we're going to run a sudo yum update so that it will actually load in this repository. After the update is completed, my particular image that I was working off of had some updates to Ruby, so I went ahead and installed those. They didn't take too long. Hopefully yours didn't either. But now we're ready to actually install Nginx. So we're going to use sudo yum install-y Nginx. The -y just says yes so that it will actually go about installing it instead of prompting us again. Once Nginx is installed, we now have access to an Nginx binary, but we're not going to utilize this directly in order to interact with our server. We're instead going to use systemd in order to run the Nginx server for us and also to start it when our system boots up. So for that, we're going to do sudo systemctl start Nginx, and then sudo systemctl enable Nginx to make sure that it starts on boot. Now if we curl localhost, we can actually see that there's an Nginx page for us, and if we go and we grab the public IP address of our server, we can copy this, and if we paste it in here, we can go and see the actual HTML render to the page. So now we're using one of the Linux Academy COD servers, and we have Nginx installed and running by default, so anytime that this server might stop and you have to restart it after you haven't been working and following along with the course for a little while, Nginx will by default be running already. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we are going to go through installing the latest stable version of Nginx on an Ubuntu 16.04 machine. If you already installed this on a CentOS machine and you plan on using that to follow along, then go ahead and mark this video as complete and continue on. If you'd rather use Ubuntu though, let's go ahead and click on Cloud Servers here and select from this dropdown Ubuntu 16, and then create the server. Once the server is started, we're going to go ahead and click Login. And then from this terminal, we are going to go through and install Nginx. So default user is going to be user with a password of 123456. And then we need to re-enter that password before we can change it to a new one. Looks like there are some packages that can be updated, so we're going to go ahead and just get things up to date right away. Now that we've updated the packages, you might think to look using apt cache to just see if there's already an Nginx that we know about. And there is. The problem is that it's kind of an old version, so this isn't what we want. We actually want the newest stable version of this. And to get that, we're going to add the official Nginx apt repository to our list of sources. If we come over to nginx.org, this is going to be where you find all the official documentation for Nginx, not to be confused with nginx.com, which is kind of the money-making side of Nginx. But there's a page on Linux packages, and this will go through and kind of show us what we need to do. But the main things that we need to know right now are that 1604, our code name is going to be Xenial, so this is going to be important to us in a little bit. And then we need to get the key that we're going to use and add that to the apt key registry. And then we need to add a couple lines to our apt sources list. So this is the key. And if we copy the link location, we can actually go and pull this down and then add it using this line right here. So let's come back over to our terminal and do that now. And now we need to use sudo apt key add Nginx signing key. So looking back at this documentation, it's now telling us that we need to edit the apt sources, and we're going to want this for Ubuntu here. And then we're going to have to substitute out this codename bit. So we're actually just going to copy these two lines. And then we'll come back over and we'll use sudo vim etc apt sources list. And then down at the very bottom of the file, which you can get to by capital G and then insert mode as I if you're unfamiliar with Vim. And then we need to substitute out codename with Xenial. And I guess we can leave a comment here. Official Nginx repository. We'll save this using :wq. We'll run sudo apt-get update. And now that we're pulling from the proper repository, we can use sudo apt-get install Nginx. Now that we have Nginx installed, we're going to use systemd in order to run this. So we'll use sudo systemctl start Nginx. And the lack of output is a good thing for us here. And then we'll also do sudo systemctl enable Nginx to make sure that it's started every time we restart our server. The last thing we're going to do here is we're going to come back over to our Linux Academy cloud server listing, and we're going to stop the server, and then we're going to restart it. Now that it's stopped, we can go ahead and start it. And then once we have the public IP address again, we're going to open that up in the browser to make sure that we can see the static HTML that Nginx should be serving up. My server is started back up, so I'm going to copy this IP address and open a new tab. And we can see that we have an Nginx HTML page presented to us. So now we have a running server on Ubuntu 16.04, and you're ready to continue on with the rest of this course. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to get started looking at the configuration of Nginx. And if we really boil down what this course is going to be about, it's about tweaking configuration options and really understanding how we can make Nginx do what we want it to do. And to get started with that, we're going to look at the default configuration that Nginx comes with, because that includes an overall server configuration and the very first virtual host that we're going to work with. So we're going to maybe make some modifications to that default virtual host, and we're going to see what the out-of-the-box settings are for the overall server. This video, along with most of the other videos throughout the rest of this course, are going to have us using the root user, because in order for us to edit files where they are by default to configure Nginx, we need to be the root user or use sudo. And then in order to interact with systemd, which we're going to use quite a bit, we also would need to be sudo. So if you want to see what user I'm using, you can check right here. This will tell you my host and the user I'm using, and it'll be root most of the time throughout this course. So we're going to change over to do that right now by doing sudo su, and then we're going to put a dash, and this will send us to the home directory for the root user. And now we can see that I am the root user, and we're going to go into the etc Nginx directory. The etc Nginx directory is going to be where all of the default files that came with Nginx, well, not all of them, there are some spread throughout the system where it makes sense, but this is where the configuration of Nginx is really going to happen. And the main server configuration happens in nginx.conf, and then our virtual hosts are going to go into the conf.d directory into .conf files within here. But we're going to see how that works in just a second, and we're going to start by taking a look at etc nginx nginx.conf. And we're going to go through and kind of learn what's going on with this particular file. So to get started with Nginx, we need to kind of understand where we're working, and that's the context of things. You can see that events has these curly braces afterward and some indented content underneath, and that means that this worker connections line is in the context of the events directive is what that's called. So this is going to be, you're going to see the words directive and the word context quite a bit when we go and look through the documentation. So that's one thing to note, is that some of the directives we use have their own content blocks. So they have context. And then others, like user up here, this is just a single directive and it's working on the main context. So it's outside of the scope of something like HTTP or events. And if we kind of just go from top to bottom within this file, we're going to see that the user is set to Nginx, and this is a system user. It's not one that we're going to be able to sudo into, but this is the default user that the child processes are going to run as, or the worker processes. Worker processes gives us the number of processes to use, and currently it's set to 1 by default. This is one of those particular pieces that you can modify based on the server that you're running this on to get the most performance out of Nginx. As we continue, airlog specifies the log file that you want to use and then the log level that you want to use. And the last of the top level contexts are going to be the PID. So PID specifies the file that you would like to hold on to the process identifier for Nginx as the server is running. And everything else in this file is going to fall within a context of some kind. The events context is required. So if we did not have this in here, we would get an error that we couldn't actually run Nginx if this didn't exist. All of these up here are actually optional, and you don't need to specify them for the most bare bones configuration of Nginx, but you do need to have events. This can be empty, and you don't have to actually specify anything in here, but it is necessary. And what events does is it's a context that allows us to configure how connections are handled to our worker processes. And in this particular case, we're setting worker connections to 1024, and that means every individual worker process at any point can have 1024 clients connected to it. Given that we only have one worker process here and a connection limit of 1024, if we happen to have 1025 simultaneous connection attempts, 1024 of them would actually be able to make a connection, but one of them would have to wait until a connection opened up. From here, we're going to continue down, and I'm going to get the HTTP section in its entirety. But HTTP lets us specify the configuration of the HTTP handling of Nginx. Nginx can handle more than just HTTP, is one thing we are going to learn throughout this. But for the most part, that's what we're going to use it for. I'm going to bring up that you can use it in order to work with as a mail server if you wanted to. But for the most part, this entire course is going to be focused on using it as a web server and as a reverse proxy and as a load balancer, because that's really how Nginx is used in real-world use. But as we go down here, we can see that there's this call to include, and what this will do is it takes another configuration file of some kind, and it's basically going to take all of the configuration from within this file and kind of just expand it into this particular context. This is what allows us to divide out our virtual hosts into separate files, even though in reality we need them all to fall under an HTTP context, but we can load them in and not really worry about where they happen. In this particular case, we're going to move all of the MIME type definitions, which is file types and the associated content types that browsers need for those. We're going to move those into their separate file, and we can actually open this file if we wanted to take a look at it by doing :E, and then it's going to be in MIME types as a file. So you can see here that there is a types directive that has context, and then you can see that text.html is a type, and that's the type that we're going to return if a file ends in HTML, HTM, or SHTML. Text CSS is the type we should use for CSS files. So this is how Nginx knows, based on the type of file that we're serving up, what context type to return to the user. We can switch back to our previous buffer using bn if you're following along in Vim. So that allowed us to take that entire types context, move it into a separate file so we didn't really clutter up this file. And that's the real value of includes, is it lets us break our things into reusable chunks potentially, or into chunks that make sense. So MIME types kind of make sense to be all grouped together. We're going to put them in a separate file. Default type will state if it's not defined in the MIME types file for the type of file that we're serving up, we should use application octet stream for that, and that's totally fine. If we look at directives in general, you'll notice that it's a directive name. This is kind of like a function. and it has a list potentially of arguments, and it's always going to end in a semicolon. Continuing down the file, if we look at the log format directive, this is going to take a string that defines how we're going to put the information that is variable from a request into a log format. So when somebody actually accesses our server, we're going to put it in the access log, which that's what the access log directive does. It lets us specify the file we want all access to the server to be logged to. But then this string defines the information that we actually want to log into that file. And everything that starts with a $sign is going to be a variable of some kind that we're going to have access to from within Nginx. Later on, we're going to utilize these quite a bit as we modify headers and as we do things like rewrites and redirects. And I will show you how to figure out what all of these variables are and what the actual options that you have are for other variables, because there are quite a few more than just what we see here in a later video when we actually go through and kind of work on logging and do the redirects. But just know that this is how the default log format is going to be specified for the access log. We only have a few more to go through here, but send file, we're going to set this to on. And what this will do is actually allow it to use the send file system call to deliver content. And this will give you a performance gain in some situations, and there are other situations where it will not. And we'll talk about those later on when we talk about improving the performance of Nginx. But now we get to see our first comment in an Nginx config. It's going to be using a hash sign or a pound sign or an octothorpe, depending on what you call it. But yeah, so TCP no push is commented out. We'll talk about this a little bit later, but as we continue on, we'll see these sort of comments, and we'll use these as we document things that are going into the virtual host files that we're working with. Keep alive timeout specifies how many seconds we should keep a connection open before we recycle it, and it goes back into the connection pool. gzip is going to be some compression that we're going to talk about later on when we talk about improving the performance of Nginx, but you can specify it whether it's on or off. And then lastly, probably the most important line of this entire thing is going to be another include statement that looks in the conf.d file and then loads in every file that ends in a .conf. And what this allows us to do is break up all of the virtual host server configurations that we want to have into separate files so that they're logical and they make sense, and we can have them all separated. And also the default.conf is going to exist inside of this directory too. And then it will load all of those things in when the server is started. And we don't really need to come in here and modify the nginx.conf file at all unless we want to change settings that would affect everything kind of globally. We're going to spend most of our time in this course inside of files that are located in the conf.d directory, but it's good for us to know how the overall server is configured. In the next video, we're going to take a look at a default.conf, not by actually looking at the file that's there, but by deleting the file and building up an entirely new default.conf that allows us to understand every single line that it takes to build the simplest possible HTTP server for a virtual host. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at setting up our first virtual host and reconfiguring the default virtual host so we know exactly what's happening when we send any HTTP traffic to our server. And the first thing I want you to do is to make sure that you're logged in as root so you don't have to sudo for everything. But we're going to remove the conf.d default.conf file. We're not even going to take a look at it. If you take a look at it, you'll have a little bit of an idea of kind of where we're going, but we're going to make something a little bit different than this file in its place. So we're going to remove that. And we did that for a few reasons. One of them is so that we can see that even though that holds the default configuration, if we currently curl localhost, we're still going to see the Nginx file. And that's because the configuration of Nginx has to be reloaded before it takes effect. And this next line is something we're going to do quite frequently throughout this course. We're going to do systemctl reload nginx. That's going to go off, and if it doesn't give us any information, that's hopefully a good thing. But now we can do systemctl status nginx and take a look at what we're actually seeing here. We can see that based on the green there, that it is active and is currently running, and that it had reloaded the configuration for us. Now, if we curl localhost, we're going to see that we failed to get a connection and it was refused. Time for us to slowly build up our default configuration again. For that, I'm going to use Vim, use whatever text editor you would like to. We're going to go into conf.d and create default.conf again. The actual name of this file doesn't matter, but this is a kind of a standardized name to use. And if we hadn't deleted it, it would already be there and you'd probably not mess with it. But I want you to understand what exactly is happening. And we have a blank file, and how do we actually configure this? And if we think about virtual hosts, they're all individual server configurations, and that's actually what we're going to need. So we're going to take a look at the documentation for Nginx a lot throughout this course, and in particular, if you want to get to the documentation that we're going to be using, you're going to go to documentation, and then there's a lot of the module references down here. And this is where we're going to spend most of our time. There are guides and other things up here that you can take a look at if you want a little bit more material. But for this, I want you to understand how to read the core documentation for Nginx, because to really get a good understanding of a tool that you're using, you're going to have to read the documentation, and it's going to be infinitely faster for you to know how to reference the documentation than it is for you to ask someone else for help, because undoubtedly you're going to have to wait for that other person who's helping you to actually have time to answer you. But if you can answer your own questions, then you're in a really good spot to be very efficient at using this tool. In this case, we're going to go into the HTTP core module. And this has a lot of the directives that we're going to use in order to just interact with a bare bones HTTP server. There are other modules that are baked into the Nginx binary that we're using that'll let us do extra things, but these are going to be the ones that we rely on, and they're there by default with Nginx. And the first one is going to be server. Clicking on that link, it takes us down to the actual directive. And if you want to quickly move through the documentation, you can take everything after this, the octothorpe or pound sign up here. You can take that and put in the actual, you can put in the name of the directive you want to use if you know it's located in this file, and you'll actually be able to find it pretty fast. But in this case, we're going to look at the syntax. So server takes curly braces because it is a directive with a context. And then it has no default because there is no default server by default. And then this context value tells you where you can put it. So a server can exist within an HTTP context. And since we are including all of the .conf files from within conf.d, by putting a server at the top level of one of these files, it will be included into the HTTP context of the nginx.conf file. So this is where we create all of our configuration for a virtual server. And these can be IP-based or host-based. And it's where we're going to specify the port we're listening on and what files to listen to and how to actually process different paths. This is where most of everything we're going to do with Nginx as an HTTP server is going to happen. So let's go back over to our configuration tab. And in here, we're going to insert a server context. And then we want to listen on port 80. That's the default port for HTTP connections. And then the next thing we need to do is we need to specify the root of files that we're going to serve. And at the end of the day, really what Nginx is doing for us on the HTTP side of things is it's going to serve up a directory when somebody's trying to access it through HTTP. So if we tell it the root to serve from, then all of the relative paths from there will just kind of point to the files within the directory. And this is what was happening before when we saw the default index page for our server. We can set this by using the root directive, and then we're going to point it to the same spot that the original one was pointed to. So that's going to be at /usr/share/nginx/html. And this is going to be a directory that includes HTML files. So for now, let's stop right here and see what we can do. We're going to save this with :qw. Nginx provides us with a way to check the configuration of our server without us needing to actually reload it. And that's by using the Nginx binary and then the -t flag for test. And it's going to go off and tell us if our configuration syntax is okay and whether or not the kind of a fake reload of it actually would have worked. And in this case, it's saying that it's valid. So we can do systemctl reload nginx again. And remember, the last time we tried to curl localhost, it didn't work for us. But if we curl localhost again, now we can see that exact same index.html file. And we're serving that out of /usr share nginx html. So let's take a look in that directory. So we'll ls usr share nginx html. And in here, there are two files. There's a 500.html, which will allow us to have that as an error page. And then there's an index.html. And this is how web servers in general work. Index.html is a special file name, and that's the one that's going to be served up by default if you reach a directory being served up by a server. If you go to the bare root of that, it's going to serve up the index.html if it has one. If we wanted to go and copy our IP address again and open a new tab, if we connected to /index.html, it would serve us the same file, but we could also come in here and connect to 50x.html, which is that other HTML file, and we'll see what that file is. So that's really what's happening, is everything inside of that directory is being served up as from the root of our server here, and index.html is going to be the file that's served up by default. So next up, we're going to go back into our configuration file. And within here, we're going to take a look at what is sort of going on and how we can make this stand apart as being the default configuration so that we can, in a moment, add another virtual host. Let's go to the documentation and look and see how exactly listen works. So we're going to come up here, and instead of server at the end of this URL, we're going to put listen. And that's going to take us, and the syntax for listen is quite a bit more complicated than server. There are a lot of different options and different ways you can use it. So we're currently using the second option where it's port, and then these things in square brackets are all optional flags that we can set to it. But default server is one that is unique in the sense that what this will do is say that if some traffic comes in and we don't recognize the host name, then this will be the server that is used by default. And that's something that we want to do in our default.conf, is we're defining what the default server should be in this particular situation. So we're going to want to use that flag. And if you look down, you can see a lot of different uses for listen, like 127.0.0.1. So in this case, you're specifying the IP address and the port you want to actually listen on. So this is the internal one, but you could specify it to listen to your public IP address and a port if you wanted to, or in our case, we're just listening on the port. The other thing that we're going to want to use is going to be server name. And the way server name works is it lets us specify what this server block is doing for a given name. So in this case, if we wanted to specify something for example.com and www.example.com, if the request coming in was for either of these hosts, then it would know to use this server block instead of using a different server block. This is how we can specify multiple virtual hosts on the same machine, is by declaring different server names. So with this in mind, let's go back into our default configuration file, and we're going to adjust our listen line so that we are using the default server. And that means that if any traffic comes here and it has a host that we do not recognize, or it doesn't have a host value at all, it's going to go to this server, even if we have multiple server blocks. And then we don't actually need this because there's a default, but I like to be explicit. We're going to set server name to equal _, which is a placeholder value, meaning that it's a throwaway value. We don't actually need it. So that's what we're saying here, is that this is a server that doesn't have a name. And like I said, this is us being very explicit, but I like to do things like this so that I can see them, if I had them side by side, what the differences are between two things. So we're going to specify that this is the default server for port 80, and it's also a nameless server. So let's save this and quit out. And then we're going to actually set up another virtual host before we reload anything. If you want to make sure that nothing is broken from what we did there, you can do nginx-t again. And I encourage you to test the configuration changes that we make quite frequently. But the next thing we're going to do is we're going to create another file inside of conf.d. And this is going to be example.com.conf. So as long as it ends in a .conf, it doesn't matter how many other dots are in it. So we can use domains in order to separate these file names. We're going to create a server block because that's going to be required. And then this is where we're going to set up that if some traffic comes in on port 80 that is using the host of example.com or www.example.com, then we want to serve up some different content for it. So port 80 is what we're listening on. And then the thing that's going to distinguish it is going to be server name. So this can be a list like we saw in the examples, but we're going to do example.com and www.example.com. And we're going to use variations of example.com throughout this course because nobody owns example.com, or no individual would own this. It's kind of a reserved domain that is for example purposes. And then the root is going to be at var www.example.com/html. And this doesn't exist yet. We're going to actually create these directories that we need, but this is a way that we could separate out the HTML for our virtual hosts, is we can put them in a, their variable content. It's going to be inside of a www directory, just saying this is web content. And then we can split them off based on the virtual host name that we want to use. So let's save and quit with this file. And now we need to make that directory. So that's going to be at var www example.com HTML. And by passing the -p flag to mkdir, we're going to create all of the directories in this chain. And then we're going to create an index.html file so that we can see the differences in the content. So this is going to be hello example.com. And then we're going to put that into var www example html index.html. Let's test our configuration using nginx-t. And this works. So that means it's loading multiple .conf files from conf.d, and they're all still working. And now we're good to systemctl reload nginx. And if we check out the status of this, we'll see that it's currently running also. To see the differences, we want to curl localhost like we have been. And we'll see that this is a much more complicated HTML file than what we had written to our example.com. And then the way that you can test out different hosts or virtual servers on here by using curl actually is going to be by doing curl, and then you can specify a header flag, and then it needs to be host, space, and then the name of the host that you want. So if we do example.com, and then you give it the actual IP address to go to, or the location, so localhost will point it to our current server. And when we do that, you see that we get a 403 forbidden error. And depending on the system that you're working on right now, you might not have actually gotten this error at all. And that's because this is from SE Linux. This is a security setting. We're trying to serve up a file using Nginx in a directory that is not specified as being allowed to be served up by Nginx. To see what's going on here, we can use less, and then we can go to the error log that we looked at, or that we know exists from the nginx.conf file. That's going to be a var log nginx error.log. And then we'll go to the very bottom, which I guess there are only 2 lines, so we didn't need to go very far. But we can see here that there is a permission denied. And this is one of those situations that when we see this, it's kind of pointing us towards we're having an SE Linux issue. If you're on a system that doesn't currently have SE Linux enabled, then you wouldn't have run into this issue. You're just serving up a file, and Nginx is probably allowed to do that for you. But we are going to need to fix this. And to do that, we're not going to cover all of SE Linux. That's a really big topic and way beyond the scope of this particular course. But I'm going to show you some little tricks in order to kind of make some modifications and see what's already there in the configuration to add more things as we need them. But the first command that we're going to use is going to be se manage. And then we want the file context. And we're going to list those out, pipe that to grep. And then what we want is we want to see if there are any permissions that are made for USR share Nginx HTML, because we know we can successfully serve content from that directory. So if there's anything in here about that directory, we can basically copy that and use that same sort of configuration. This line looks a little bit like gibberish, but basically what it's saying is that for any file, this is a regular expression, any file inside of this path, which is the path that we care about, that this type right here is allowed. So it's allowed for all of those files. So httpd sys context t is the type of rule that we're going to be using inside of SE Linux. And this might seem weird that it has nothing to do with Nginx, but httpd is Apache, and that's kind of just been the version that we're using for anything that's a web server. So we're going to copy this portion. And then what we want to do is we want to do se manage fcontext again. This time we're going to add it. It's going to have the type of that. And then the string is going to be the path that we want. And it's going to follow a very similar pattern to what we had right here. So it's going to be anything inside of var www. And then we're not going to include the slash. We're going to instead put that inside of this capture group. And then we'll close that string. If we go and list, let's just make sure that that error isn't actually something we should be worried about. Turns out there are a bunch of very specific locations inside of var www that are allowed to be served out. But we wanted ours to be a little bit more generic. If we scroll all the way up to the top of this, you can see that the line we actually care about is there. So we're almost done fixing the issues that we were having with SE Linux. In order to actually get the files that we created and the directories that we created to have the proper labels on them for SE Linux, we have to use restore con, make this recursive, verbose for var www, and that will go through and it restores the information for our index.html, the example.com, and everything inside of there. So now everything should be able to be served up. And indeed, if we do curl header host example.com, and this is very specific, you have to have a capital H on the host and put a space between the colon. Its headers are fun. But now if we send this particular one, we should see that we're getting our example.com. And if we repeat the exact same line with the www, we can see that we get the same thing. So it works for both of those hosts. So in this video, we created the default configuration that's actually simpler than the default configuration that exists by default, because we're going to kind of build up some more of those things over the course of the next few videos. And we also created our first specific virtual host for a host named example.com and www.example.com that can serve a website from a different directory. And we battled SE Linux along the way. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at how we can customize when things go wrong with Nginx. Specifically, in this case, it's going to be when there is a server error, so a 500 error of some kind. And then also what we display to the user when there is a 404 error. So that means that the content they're looking for isn't actually there. Let's take a look at what happens right now when we receive a 404 error. And we can do that by curling localhost for any file that we know doesn't exist. Fake.html we know doesn't exist. By default, Nginx has actually created a 404 page that it will display for itself, but we can overwrite this, and we really should. If you take a look at this page inside of your web browser, you might actually recognize it from going to some other services. It's pretty simple, but you're going to want a custom one for your particular web service that you're working on or your website, and it's pretty common to kind of keep the branding going throughout the entire thing. So that's what we're going to figure out in this video, is how we can customize what happens when errors happen. This course isn't going to cover creating attractive looking HTML pages, so we're going to use pretty simple HTML for the most part. But we're going to set up what happens on the default server when something goes wrong by going back into conf.d default.conf and setting it up inside this server block. The first thing we're going to do is look at the documentation for what we actually need. And if we search, if we go all the way to the top and we search for error, we can see that there is an error page directive. And if we click that, we can take a look at the syntax that we've got. And let's break this down. So code is going to be the HTTP status code that we want this to work with. But you'll notice that there's a ... here. And this means that this is a list. So you can have a list of codes. And then at the end, you can either specify a URI to render out, which is going to be some sort of path. And then optionally, you can specify a different status code to return in this case. So sometimes you want, if there's a 404, you actually want to return a 200 error. I would say don't do it, but occasionally this is something that you're going to want if you're working on some sort of service. Going down, there's not a default. And the context, this is the first time we've seen it, but you can actually define the error page in multiple different places. So we could put it at the top level outside of any server. In this case, the 404 page is going to be something that we want to customize for every single web host that we have, most likely. So in that, we're going to put it inside of our server block. But we could actually put it inside of a location block, which is even more fine-grained than server. It's going to be something we're going to work on inside of a server block. So you can have different 404 pages, for instance, for different areas of the exact same virtual host. If we look at the examples that we have here, this is actually pretty much what we want. And it's going to be the error page directive followed by the code. 404 is a unique one. It stands for file not found. And then the URI that they're using is /404.html. And that just means that they're going to have a 404.html file inside their current root for their virtual host. And we've actually already seen the 50x.html. So if we take these two lines, this would set up exactly what we want to have inside of our default server. We're not just going to copy and paste them. We're going to go back over and kind of talk through this a little bit more while we write them. But what we're going to put here is going to be the error page 404 to /404.html. And then we're going to save this, and we'll come back and add the 500 error pages later on. But we're going to save this one line, and then we actually need to create that, because if we look inside of USR share, not dict, Nginx, HTML, you'll see that there is no 404 page. So we need to create that first. Let's do that by doing nice h1 tag, 404 page not found. Close our h1 tag, and we're going to put that into USR share Nginx HTML as 404.html. Now, once again, we made a change to a configuration file, and that's not going to be picked up by Nginx until we reload it. So we need to do systemctl reload Nginx. Now, if we curl localhost fake.html, we'll see our customized version of a 404 page, which has less going on than the normal one had that Nginx kind of generates for itself. But it's something that we can actually know exactly where it's at, and we can make modifications to it. Let's open up our default.conf and finish setting up these for the 500 errors. So we're going to do error page, and then we'll do 500 all the way through 504. So 501, 502, 503, and 504. And then this is going to render out the 50x.html that we already know exists. Oops, forgot my semicolon. If we save and we reload Nginx, it will pick up that change. There's not really a good way for us to simulate a 500 right now. We will know how to do it using location blocks a little bit later on, but for right now, let's just trust that since it worked for the 404 page, it's probably going to work for the 50x page that we already had created for us. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at how we can take one of the virtual servers that we're working on, and we can specify to do different things based on the path that we're given. In doing this, we're actually going to set up a specific path that will require a little bit of authentication using HTTP basic auth, so you'll also know how to secure areas using that very specific type of authentication. To get started, we're going to need to learn how to specify different paths to be handled differently, and that's going to be within the core module again, and instead of error page, which we were previously looking at, we're going to use the location option. And location allows us to set a specific block of configuration that will occur when there is a matching URI. And the URI can be specified in different ways. You can have it be an exact match using an equal sign, or you can have it use a variety of regular expression-based matches, and then it is a context, so it'll take curly braces, and then we can have nested configuration underneath that, and it can go inside of a server or inside of a location, so you can deeply nest locations if you'd like. In the particular case that we're working with, we want to say if somebody goes to a /admin.html, we want them to be required to log in before they can actually see the contents of the page. So let's set up our location block first, and then we will worry about the authentication. We're going to go back into conf.d in the default.conf. And then I like to keep the error pages at the bottom of the configuration, but we're going to have a location, And then this is going to be equal because we want it to be exact. And if it matches exactly at admin.html, then it's going to fall into this particular location block. Now, the basic auth portion of this is actually going to be found in a different module than what we've currently been working in. So if we go to the root of the docs, we can see everything here once again, but there's an auth basic module in the modules references. So we're going to open this one up, and I'm going to open this in a new tab so that I don't have to continually jump around to get to the root. But this is more or less what we're going to be doing. You'll notice that directive-wise, there are only two, and we have to use both of these in order for this to work. But the auth basic directive is going to take a string, and this is going to be the message that is presented to the user when they are prompted to log in. So you can say something like login required or password required for access or some string like that. The actual value of it doesn't really matter as long as you don't send in the word off by itself. This disables the basic authentication, and it's disabled by default. And then you'll notice that we can use this within a lot of different contexts. But the more interesting of the two directives is going to be the auth basic user file, which takes a path to a file. And this file is one that contains usernames and then the associated password for the user. But these passwords are going to be encrypted. We're going to utilize the htpasswordD utility that can be installed on virtually any system. You could also use OpenSSL to generate a password if you wanted to, but I like to use this utility. But this is what we're going to have to set up. We have to create the file, and then we have to set up both the auth basic and the auth basic user file directives inside of our configuration. So we're going to start with the configuration, and then we're going to generate that file. We're going to use auth basic, and then the message we want is going to be login required. And then as we go over here, we're going to have auth basic user file. And this is going to be an absolute path. It's going to be at etc nginx. And then we're just going to put the ht password file here as a hidden file. Let's save this and quit. And now we need to actually generate that password file. And like I said, we're going to use the htpasswordD utility, which isn't going to be installed for us by default. So to get that, what we're going to do is yum install httpd tools. And if you're using an Ubuntu or Debian system for this, it's going to be the Apache 2-utils package. But we're going to install this, and this will give us access to that very specific tool. Now if we do htpasswordD, we're going to give it a -c flag so that it can create a file for us. That's going to be at etc nginx dot ht password. And then the username we're going to use is going to be admin. And then it's going to prompt us for a password, which I'm just going to use password. And then it's going to prompt us to make sure it gets the right one. Now we've created all of the files that we wanted. Let's go ahead and make sure our configuration is good. Looks like we didn't have any typos in there, at least not any that would break the configuration. So finally, we can use systemctl reload nginx. And if we use curl to go to localhost/admin.html, we're going to get a 401 authorization required, and that's because we didn't pass any sort of thing, and curl's not going to know how to answer that. It's not going to prompt us. So we actually have to pass in some flags to curl in order to check this from the command line. That's going to be curl-u for user. It's going to be admin, and then the unencrypted version of the password. And we'll point that back to localhost admin HTML. And then we'll get a 404 not found. So we'll see that there are differences going on right there. We actually forgot to create the admin.html file. Let's go ahead and do that now. And this is just going to include admin page. And then we're going to put this in USR share nginx HTML admin.html. Now if we try this curl again with our username and password, we're going to see that the admin page is displayed to us. This works a little bit differently if you go and actually try to visit it from the browser. So if we change this out to be admin.html, it's going to actually prompt us for it. And you'll see this is where our login required message comes up. And we'll say admin and password. And now we can see the admin page. Let's take one last look at the configuration that we made for this particular video inside of default.conf, and it's really all inside of this location block. So what we did here is we specified that if somebody goes to this exact path, then they need to be handled a little bit differently than if they go to any other path. So in this particular case, it's going to prompt for login using authbasic and the authbasic user file, which we created using the htpasswordd utility. But if we go back and we go to something that's not the admin.html, it'll still work for us just fine because that's served up from the root itself. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a break from modifying our Nginx config to actually generate a self-signed SSL certificate so that we can start looking into how to set up our server to respond to HTTPS requests, which talking over SSL and TLS and having more security to our server is something that's really paramount nowadays. So for right now, we're going to do some self-signed certificates. That way we can figure out how to configure this, even though it's not going to necessarily be secure from the browser standard. The first thing we're going to do is, while being the root user, we're going to make a place to actually put these. So we're going to use mkdir, and then I'm going to put mine in etc nginx SSL. And then we have one command that we really need to do for this. So we're going to use the OpenSSL utility, which should be installed by default. And then we have to make a certificate request. And I've linked to the documentation for this particular thing, but there are a lot of flags that we can go through. And we're going to discuss these as we actually type them out. So the first thing is the rec subcommand, which is just saying we're going to make a certificate request. Next, we want to pass -x509. And this is stating that we want our certificate to be in the x509 structure. We're going to do -nodes, which says to not encrypt the output key, -days, which allows us to set the expiration of this particular certificate, which we'll set to a year. And then we're going to start putting these on their own line. The next one we want is new key. And then this is stating how we want to generate this. So what type of key we want. And for our new key, we're going to use the RSA encryption type, and then it's going to be 2048 bits in size. We want to set an output key, so key out, and this is where it's going to put the private key for us. So we're going to put this in etc nginx SSL private.key. You can kind of call this whatever you want. I just like to be specific in saying that this is the private key. And then the last one we want is going to be the output file for the public portion of our certificate. So we're going to put this one in etc nginx SSL also, but we're going to call it public, and then we'll use .pem for this one. When we hit enter, it's going to prompt us for some more information. If you don't actually want to put anything, you don't have to for some of these if you're just self-signing, or if you want to put your own company's information. For right now, we're just going to kind of skip through these. Now, if we take a look in etc nginx SSL, we should see that we have both a private key and a public.pem file. And in the next video, we're going to utilize these to allow our server to accept requests via HTTPS. Welcome back to the Linux Academy Nginx Deep Dive. In the previous video, we generated our own self-signed certificates, and in this video, we're going to change our default server configuration so that we can handle HTTPS connections. To do this, we're going to work from a different module than the core module or the authbasic module that we spent a lot of our time. If we scroll down a little bit more, you can see that there is an SSL module. There are quite a lot of settings that we can use for SSL, and we're going to utilize more of these as we continue on through the course. But in this video, we're going to create the simplest possible SSL configuration that we can do for one of our virtual servers. I do want to call out that the SSL directive is no longer used. The SSL directive is no longer used, and you should instead use it with listen, which we'll do. But for us, the two that are going to be really important are going to be the SSL certificate and then the associated SSL certificate key file. The key file takes the private version, and the SSL certificate directive takes the public version. And you'll notice in the example down here that it can handle multiple different types too. So you can have an RSA version, and then you could also do a different type of encryption for your certificates. We're using RSA, so we only need one pair of SSL certificate and key directives. But the rest of this is actually pretty important. You'll see that we are listening on port 443, which is the default port. That's if you go to https:// any website on the internet, it's going to, by default, connect to port 443. And then we want to utilize SSL. So this is another one of the optional flags that you can pass to the listen directive, similar to how default server worked for us when we were working on port 80. So now that we know we have two directives to work with, the SSL certificate and SSL certificate key, and they both take a file, I think we're ready to go modify our configuration. So from here, we're going to open up the conf.d default.conf. And although we already have a listen directive here, we can add a second one if we want to use the exact same server configuration for both HTTP and HTTPS traffic. So we're going to listen on port 443 using SSL. And then we're going to continue on and add in our SSL certificate, which is going to point to etc Nginx SSL, and then we called it public.pem. And then we'll also add an SSL certificate key that goes to etc Nginx SSL private.key. And now we can save this. If we run this through nginx-t, we'll see that we didn't have any obvious typos that would cause error. And now we're ready to reload this using systemctl reload nginx. To test this out, using our browser, we can come over here and add an HTTPS in front of our actual public IP. And this is what you're going to see. And it says your connection is not secure. This is considered an error, and that's because we're using a self-signed certificate. To get back from this and actually see the content, you're going to click Advanced. Or if you're using a different browser, you might see something else. But there's going to be something that you can click that can basically get you to add an exception, and then you can confirm the security exception. And that just means in this particular case that we're still using SSL, but the security isn't considered good by the browser because we're using a self-signed certificate. If we go to admin.html, it's still going to prompt us for our username and password. But you'll notice that we continued to use HTTPS, and that worked out just fine. Before we conclude this, I do want to talk about how you could look at this through curl, because if we currently curl HTTPS localhost, you're going to see that it's actually insecure. But thankfully, this error message is pretty useful, and it tells us that if you want to skip the verification of certificates, you can use -k or --insecure. So if we do -k and we connect to HTTPS localhost, you'll see that it actually showed us the default index.html page that we've been working with. Just to recap, setting up the simplest possible SSL server required us to use 3 lines. We had to listen on port 443 and specify that we were using SSL for that. And then additionally, we had to specify the certificate to use and the private key associated with that certificate. Welcome back to the Linux Academy Nginx Deep Dive. In this lesson, we're going to go through and look at how we can use rewrite rules with Nginx. And rewrite rules allow us to modify the URL as it's coming in. We can either modify it and then redirect so that the URL you end up on matches what we want it to be, or we can modify the URL before passing it into our location blocks so that it can be handled. In this video, we're going to go and remove the HTML aspect of things from the end of our URL. So we're going to try to remove the file types from what we've got and still have the same content be rendered out to us. This is a fairly common thing. These are kind of vanity URLs. They look a little bit better if you don't have to have the .html on the end. And it also provides a way for you to kind of hide your infrastructure also. So if you're using something like PHP, if you really wanted to, you could remove the .php from things and you could still render out a PHP page. We're going to get started the same way we have been, and that's by looking in the documentation. And a good rule of thumb is that if you know kind of what you want to do in the domain language of web servers, then you can just kind of search for it. Like we searched for SSL and we found the SSL module. And if we search for rewrite, there will be various things in here about rewrites. So we're going to look at the HTTP rewrite module, and it's another not huge module. So it's a relatively small module that gives us a few things that we need. Specifically, we're going to utilize the rewrite, and then later on we'll use the return also. But the way that a rewrite rule works is that it goes into a server or location block, and it takes a regular expression. And if you're not familiar with regular expressions, there's a lot you can actually talk about there. You can do a lot with regular expressions. It's a way to kind of define a pattern, and then in certain situations, you can take pieces out of that pattern and use them in a replacement. So that's what we're going to be doing here. I can't fully explain regular expressions to you, but I can go through what exactly is happening in the regular expression that we're going to use. So we look for a pattern. If it matches, we create a replacement, and then there's an optional flag that we can work with. And our 4 flag values are permanent, redirect, break, and last. You can chain rewrite rules together, and the last option will prevent you from going to the next one. So if something matches a rewrite rule that's in the middle of 4 or 5 different rewrite declarations, then the last one, if it is matched, will skip the ones that are underneath it, and it'll go on and look for a location block. Break works similarly, but it works with the semantics of the break directive. But the 2 that we're going to focus on right now are going to be redirect, which actually causes you to redirect using a 302 status code, and then permanent, which does the exact same thing as redirect, except for it's a 301 status code. And we'll discuss what the difference is with this when we get to it. We're going to put our rewrite rules inside of our default server block, and then we're going to change our locations to work off of what the new URLs are. So let's get started with that now. I'm logged in as root, as you should probably be, or you're going to have to use sudo to modify this, but we're going to go back into modifying the conf.d default.conf file. So to get started, let's write our rewrite rules right after our SSL certificates here, and that's going to be rewrite. And then we have a regular expression. It doesn't go in any sort of quotes or anything like that, but we're going to say from the beginning of the URI, which this is everything after the domain. We want everything from the beginning, and then parentheses indicate that we're using a capture group, so we can put a pattern in here, and then we can utilize the contents of this capture group in our replacement later on, but we want this capture group to include a slash, and then a dot is a wildcard character, so this can be any character after a slash, and then the asterisk means 0 or more of the preceding character. So in this case, we say we want everything that matches starting with a slash and can be any characters long after that. And then as we continue on with this, we're going to have a literal period, which means we have to escape it using a / with HTML. And then we're going to put another capture group here that includes a literal question mark, because a question mark is another special character in regular expressions that we'll see the real use of here in a second. And then another period asterisk, which means any characters after this point. So we'll close that capture group. Now we have 2 capture groups. And then we want to say that the second capture group is optional, and that's what the question mark is going to allow us to do. It's going to say whatever was right before this, so that can either be a single character or it can be something like an entire capture group like we have right here. We can say that that is either going to be there or it's not, but if it's not there, we're still going to match this pattern. And then to indicate that this would take up the entire URI, so from beginning to end, the opposite of the caret at the beginning is going to be a $ at the end. So to kind of demonstrate this, what this would turn into is if we had a URI that was admin.html, and then there was a question mark for a query string and said something like debug equals true, then our first capture group is going to return us admin, and then our second capture group is going to return to us debug equals true. It's just basically cutting out the HTML in the middle, and that's exactly what this regular expression does. And it will match basically anything that has a .html in it. So with that in mind, our replacement is going to be the first capture group, which we can reference using $1, and then the second group can be $2. And if you had more capture groups than just that, you could use $3, $4, and you could put other things in here as well. Lastly, we want our flag at the end here, and we're going to have this redirect, and we're going to use redirect, which is the 302 version, to say that we're going to point you in a different direction, but this isn't permanent. We're not saying that you should always do this without consulting us. And that's what a 301 does. A lot of browsers will take the result of a 301. So if it's redirected with a permanent redirect, if you try to go to the URL that was permanently redirected, your browser won't actually consult the server before it changes the URL for you. It will know that it needs to redirect this somewhere else, and it will go off and do that. So it's good to use partial redirects unless you know a very specific URL is never going to be modified again, and then you can use a permanent redirect. So this one rewrite rule will allow us to take in a request, remove the HTML, but then since it redirects, we're actually making another request to ourself at that point, and then it's going to be processed again. Whoops. We are going to have a second rewrite rule that is going to start similarly with a caret and a capture group. This one's going to be a little bit different. We're not going to capture the slash at the beginning, but we're going to say if there's any group of characters as our capture group, and then it ends with a slash right at the end of the URI, then we actually want to rewrite this so that it's just the initial portion without the trailing slash. And then we'll also redirect this. And this just prevents somebody from going to example.com/admin. If they do that, then it's just going to send them to /admin, and we'll handle that. Let's quit out of this file and go and make sure that we have configured everything properly. Whoops, Nginx-T. Looks like we don't have any obvious errors. Now we can do systemctl reload Nginx. And if we go over to our server and we refresh, we can see that it's taking a little bit longer and that the page isn't redirecting properly. And that's because it's redirecting forever. It's going to just continue to redirect. And what did we actually do to cause that? Let's take a look at our default.conf again and see what would be different. So we were going to the root of our server, and then we were removing the HTML from it and returning back. And we don't have any location block that would tell it how to find the actual HTML file for it. So we're running into the situation where it thinks it needs to use a 404, so it's going down to the error page 404, but the error page 404 is pointing it at 404.html, which it doesn't know how to find anymore. So this is where we get into the issue where we want to display content that does not match exactly what is requested in the URL, and for that we're going to have to use another portion of the Nginx standard library of directives. We're going to go back to the main documentation, and then we want to once again go into the core module. And inside of here, we're going to look for one called try files. And what try files will allow us to do is to take a URI and then look for a file on disk, and then we can serve the content of that without changing the URI. And specifically what we want to do is we want to take any location after our slash, and we want to start looking for HTML files that we can render out for that. So what this will give us is something where we check the URI, and this is after all the rewrites have happened. So we have this cleaned up to where it no longer has HTML in it. So if it was somebody who was going to admin.html, now they're just going to admin. And so there is no just admin file for us right now. So what it does is it takes a list of files and then eventually returns something at the end. So this URI can be a default piece of content that you know is always going to exist, or you can have it be a status code, at which point it'll go and be handled by your error code logic. So if we just kind of walk through what we want this to do, it's going to be something like admin, that it can't find that. So it's going to look for a directory called admin with an index.html inside. If it can't find that, then this person is setting up to where it's going to look for an admin.html file. If it can find this, it will render the content from this file for the given request. And if it can't find it with any of these files on disk, then it's going to return a 404. So we actually want pretty close to this exact declaration, and then we're going to need to modify our special location block that we're using for our admin.html and our error file declarations. So let's give this a shot. First thing that we're going to do is we're going to create a new location that is for slash, and this kind of happens by default for us when we just set the root. It just knows to look for files within our root. But now we're saying that if it starts with a slash, then you should fall into this block unless there's a more specific location directive that would match better. So from here, we're going to say try files, and then we want to try the URI index.html if there is one. So this is in the event that it's a directory that is underneath our HTML directory. We want to render the index.html file. If that doesn't exist, then we're going to do URI.html. If there is a directory by that name, but it doesn't contain an index.html, then we want to render the directory itself. And then lastly, we're just going to try to render the URI itself if there is specifically one that exists. And then if none of those things works, then we're going to return a 404. We're going to take this entire line, we're going to copy it, we're going to move it down into our admin area also, and then we're going to remove the .html from here, because there's never going to be a situation where the .html is still there since it's being removed from our rewrite rules. And in this particular situation, we want to say everything underneath the admin should be requiring login. And this would actually allow us to go from having an admin.html specifically to we can have a whole group of files underneath an admin directory potentially that would all require login. So this is kind of an improvement in expanding the admin area of our default site. And for now, let's just go with that right there and see if this, specifically this location /section, fixes our infinite redirects that we had. We'll test our configuration, and then we'll restart the server. Now, if we come back over and refresh the page, you'll see that going to /404 worked out just fine. If we go to the root, we're seeing the content that we expect. And then if we go to admin.html, it's going to require our password. And then you'll see that it stripped off the .html at the end here. So in this video, we looked at how you can conditionally render content that doesn't exactly match what is being requested, and how you can change the URL that you are initially receiving to match something that you want to pattern match against later on using rewrite rules. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to cover a pretty important topic really, and that is how we can utilize the information that we've kind of gained from the rewrite package and redirecting things when we get requests to force all traffic from HTTP over to HTTPS. And this should, in my opinion, really be the default for Nginx as a thing, but it can't be since you would have to have an SSL certificate. But there are a lot of benefits to using SSL all the time. And years ago, it used to be a performance hit for your server. Your website would be a little bit slower every time you serve something over HTTPS, but now is not the case. And later on in the course, we're going to cover HTTP2 or H2 as it's sometimes called. And that actually requires SSL and is faster than using HTTP 1.1. So you get the benefits of speed eventually with H2, you get the benefit of security with HTTPS, and then additionally, you also get the search benefits of the fact that Google, as the largest search engine in the world, will factor in the SSL nature of your site and give you a better rating than if you had just HTTP traffic enabled. I mentioned that we're going to be using a little bit from the rewrite module. So if we search for rewrite again in here, and we open this in a new tab, we're going to use the return keyword here. And return has three possible uses that you can have for it. You can return a status code by itself. And this is actually how we could go and test our 500 error page if we wanted to. We could just return inside of a location block a 504. You can return a code and a URL to redirect them to, or you can just return a URL to redirect them to. We're going to build up to this, eventually getting it to redirect everything to HTTPS, but let's first just get it to where every single time you try to make a request to the HTTP version of our site, that you get a 404 page. And this will require us to separate our servers into two separate servers so that they don't share the exact same configuration. And this will clean up our default configuration a little bit in that way. So if we open up conf.d default.conf again, up to this point, we've been listening on two ports for the exact same thing, but now we're going to create a separate server block that's going to listen on port 80 by default. And then we're going to give it the same server name because it is a nameless server listening on port 80. And then we're just going to have it return 404. Let's save this change. Make sure everything is good. And reload. Now, if we come back to our server and we change HTTPS to HTTP, we're going to get a 404 page, and you'll notice that this is the original Nginx 404 page that exists when you don't have an error page configured, because now when we're listening on port 80 by default, it has a very, very simple configuration with nothing extra set up to it. Since we know we have two working separate configurations, now we just need to configure our return statement to send us to the proper server using a redirect instead of rendering out a 404. And to do that, we're going to use a 301 because this is one of the situations where we want this permanently to go to HTTPS. We don't even really want to handle the HTTP traffic at all after the first time that it's been done. So we're going to use a 301, but then we also need to give the URL that it's going to. And to get it to go to the HTTPS version of things, we need to start it with https://, but how do we get it to go to the exact same URL? And for this, we're going to have to go and look at the variables that we have at our disposal when working with Nginx so that we can combine some variables together in order to recreate the exact URL that we're working with. Let's go back to the Nginx documentation, and we're going to search for variables. So you can see that there's an alphabetical index of variables here. And if we open this up, there are quite a few that we have to work with. We can kind of continue to go through here, but as we'll sort of learn some of these things, you're going to look for things with URI quite a bit. So if we search for URI, you'll see there's document URI, request URI, just plain URI. And then the other thing that we want to work with is it's known as a host for the domain. So if we look at for a host, you'll see that there is a variable for this. So this is the host from the actual request line that we have typed up in our browser or the host header that we're working with. So we want to make sure we're still sending it to the same host. And that means that if there was no specific configuration for this host, like if we don't have another virtual host for this specifically, we still want to keep that host working because it's just utilizing the default that we have here. So in that case, we're going to use this full host so that we don't lose it somehow. And then everything after the host is going to be the request URI. And this is the entire URI. So this includes arguments, which means the query string will be intact. And this is request URI is what we're working with when we're utilizing rewrite rules also. So if we go back over, what we can do here is we can just reference these variables exactly. So we'll have host, which is the first part, and then request URI. And that should redirect it to port 443, so HTTPS. And then that will go through and be handled entirely by the other server. This is all this particular server for HTTP traffic needs to do. Let's save and quit. Test the configuration. Reload. And now we'll give this kind of a more complicated case. So if we refresh this exact page, there are a couple things that are going to have to happen. It's going to change it to be HTTPS. And then once it hits the HTTPS server, it should prompt us to log in. It should remove the .html from the end. And then finally, we should have that as our whole URL. We were already logged in previously, so it didn't need to prompt us again. But if we opened a private window and did that exact same request, it would prompt us for it. And we would get redirected in this way. So now it's impossible to get to any HTTP content for our site. If we go to just HTTP, it'll immediately redirect us to HTTPS, and it doesn't modify anything else with the request that we're working with. So it didn't take a lot of configuration in order to redirect all of our traffic to HTTPS, but there are some pretty big benefits for this. So I think this is one really important skill to know when you're working with Nginx is how you can utilize the return function and the variables that you've got in order to redirect traffic to a completely different server that is handling your secure traffic. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at modules in Nginx. We've used plenty of modules up to this point, and we haven't really talked about where modules come from, how you can get more modules, how you can know what modules you have available to you. And so that's what we're going to cover in this one. We're not really going to do much with them. We're just going to poke around in the files that Nginx installed and look at Nginx's configuration to get a grasp of how modules work. So currently we're inside of etc Nginx as the directory, and we're logged in as root. And if we ls right now, we can see that there is a modules directory. And if we ls-al, we will see that modules is actually a symlink to usr lib64 Nginx modules. But what's inside of modules? There's nothing there. And this directory is actually meant to hold dynamic modules. As of Nginx 1.9.11, Nginx has had the ability to load dynamic modules, and what that meant is you didn't have to recompile Nginx entirely if you wanted to add some functionality to it. You just needed to make sure that you compiled the module with the same settings that the Nginx binary you were using it with was compiled with. And this allows you to easily add and remove modules from an Nginx system that you're working on. And depending on how you install Nginx onto your machine, sometimes you'll have modules compiled in like we've been working with, or you'll have dynamic modules for a lot of the things that we're going to look at. And this modules directory will actually have things in it. If we go over to the Nginx documentation, let's kind of take a look at what's going on with some of these. Specifically, the image filter module is one that's interesting because it goes through and lets you modify images, but you'll notice here that it says this module is not built by default. It should be enabled with -- with HTTP image filter module as a configuration parameter when you're building Nginx. So this kind of points us in the direction of how we can tell if a module has been built in, and it's going to be with these configuration parameters. But how can we see these configuration parameters is going to be our next big question. And the way that we're going to do that is by using the Nginx binary. If you use Nginx-v, you will get the version that you have for Nginx. But if you use Nginx-V, you'll get a lot more information. Specifically, you'll get the entire configuration arguments. And it's really, really long. There are a lot of arguments that were passed in here, and you'll see a lot of them can end in _module. And if we want to take all this information that we're given right here and see a nice list of the modules that we have at our disposal, we can use Nginx-V, and then we're going to use a little bit of redirection. So we're going to redirect standard out to standard in. If I can hit the right key here. And then we're going to pipe that into tr, and we're going to substitute this with new lines now, just so we get them line by line. And then we're going to grep for any of the parameters that has module in it. And when we do that, we can see all of the modules that were built in by default. These are the additional ones, and there are three main types of modules that we're going to be working with. You're going to see HTTP modules, mail modules, and stream modules. And mail and stream don't actually need to be enabled by default at all, because what you'll see up here, and this is the exception to the _module rule, is that you could compile a version of Nginx that didn't know how to handle mail and didn't include any of the mail modules by removing the -- with mail option. Similarly, the -- with stream option is there. So we could remove both of those, and then we would have a much slimmer version of Nginx that couldn't handle a lot of things. But in most situations, it kind of doesn't matter. If you have those installed, you probably don't need to remove them. You just choose not to use them yourself. But if you do want to limit the actual size of the final Nginx binary that you're working with, or the capabilities if you're letting other people do the configuration and you don't want them just randomly starting a mail server on your server, then these might be things that you want to consider. So these are the compiled modules. If you want to work with dynamic modules, we can come back over to the documentation, and if we look at the core functionality, this will give us the Nginx core module. And this will show us some extra things. So this is where include came from. This is where events and a lot of the things that we saw in the nginx.conf file. But load module is a way that you can load dynamic modules. And dynamic modules will be files that end in .so here. And this will allow you to add things in and remove things if you would choose not to use them. But when we work with modules in this course, we're going to be working with dynamic modules. It's a new feature, and it's pretty nice to not have to recompile the Nginx binary that you're already using. And this does actually mean that you can then reload your configuration and add new functionality to Nginx while it's still running. So in the next video, we are going to go through and we're going to set up everything we need to so that we can use the very popular ModSecurity web application firewall as a dynamic module with Nginx. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we are going to be adding our first third-party module in the form of the ModSecurity web application firewall by compiling the dynamic module and then including that using the load module directive that we talked about in the previous video. So to get started, we are going to yum install quite a few different things here just so that we can work with the actual build process of this, because what we have to do is we need to download the Nginx source code that is compatible with the version of Nginx that we're running. We need to download ModSecurity source code and compile the library. And then we need to use the Nginx source code to build the dynamic library using a separate package that the folks at Spider Labs have created so that you can work ModSecurity into Nginx using dynamic modules. But we need developer tools in order to do that, and then we also need some dependent libraries in order to compile everything that we need to. So we're going to use yum group install development tools. Once the development tools have installed, now we get to list out a lot of the dependencies that we need to make sure are installed for us to do this. I'm going to put them on their own lines just to make this a little bit easier, but we're going to yum install -y, and then we need geoipdevel, libcurl devel, and the reason that we have to install these packages is that they were dependencies that would have been installed when the Nginx binary that we were working with was actually built. libxml2devel, libxslt devel, libgb-devel, lmdb-devel, openssl-devel, pcre-devel, Perl extension utils embed. Whoop. Oh, and I spelled it wrong. Thankfully, if I cancel out using Control-C and push up, I can actually get them all in as one line, so that's beneficial to us, but that is the downside with putting things on separate lines, that if you accidentally type something incorrectly, you're kind of in trouble. We'll just put the rest of these on the same line, but we need yajl-devel, I don't really know how to pronounce that, and then zlib-devel. So this will go off and install these, and once this is done, we'll start pulling in the source code for the tools that we want to actually work with, and then we'll have to build some of those. Our dependencies have been installed. We're going to put this source code into the /opt directory. So from in here, what we're going to do is we're going to do git clone dep1, which means we're only going to pull in one commit, which is the latest commit. And then we're going to get the branch of v3 master. So we're only downloading one branch also. And then we're going to pull this from the Spider Labs ModSecurity. And we can actually copy this clone declaration right here. And then we can paste that into here. We want to cd into ModSecurity. This, if you're unfamiliar with Git, this particular project uses submodules, which means there are other packages that they include the source code in themselves instead of using something like a package manager. So we need to go and pull in that code by doing submodule init, followed by a git submodule update. And the build process for this particular package is going to be running build.sh, which is in the root directory. And the fatal no names found cannot describe anything. These errors don't matter. They don't actually stop. You're not running into any real problems. I'm not really sure why they log that all the time, but you'll notice if we echo the actual status of what we just did, we still get a 0. It still actually succeeded, so we're fine there. Now we need to configure, and we're just using the base configuration of ModSecurity. And you can see that this is where a lot of the dependencies that we installed were actually going to be required. So yajl it was found. It was version 2.04. So that's where a lot of this stuff ended up coming from. Now that we've configured, we're going to run make, and this command takes a long time. It can take anywhere between 10 to 20 minutes on cloud servers, just because this is a large C project, so actually compiling takes a little while. So I encourage you to start the make process and then go grab yourself a cup of coffee, and then I'll see you when we're done. Now that we've made ModSecurity, we actually need to install it, and we can do that using make install. This really just copies it into a different directory, but there's a shorthand for it. We don't have to worry about what we need to copy, what we don't need to copy, so this is a useful thing that we do. Similar to how we just built ModSecurity, now we're going to back up into the op directory, and we're going to do git clone, and it's going to be almost the same. We want depth of 1, and then this one is going to be github.com spider labs modsecurity -nginx.git. And this is the wrapper layer that allows us to build the actual dynamic module for ModSecurity. So we're going to now download the Nginx source code that we need, and then we actually will point the Nginx configure towards this module and then have it build the module for us. So first thing we need to do is figure out what version of Nginx we have. It's 12.2 or 1.12.2 rather. So whatever version we have right there, we can use wget to do http://nginx.org download /nginx dash and then that version number. So 1.12.2.tar.gz. We can unpack that using tar zxvf and then nginx. So now we have the source code for Nginx that matches the version that we're currently running. We can cd into that directory, and now we get to use configure in here. And we'll do with compat to be compatible. And then the last thing we need to do is, whoops, not that, add dynamic module. And then this one takes a path to a dynamic module, which is going to be mod security-nginx. So this builds out the make file that we're going to need. And if we just ran make, you would go and actually compile Nginx itself. But in this case, we actually just want to make the modules. So we're going to do make modules. And now if we look in the objs directory, you'll see that there is an Nginx HTTP ModSecurity module.so. So this .so is the thing that we needed in order to have it be a dynamic module. So we will copy that file. So copy from obj Nginx HTTP ModSecurity.so to, and then we can put this into etc Nginx modules. And that's the hard part for us going through and actually building out our dynamic module. So the things we needed the library for ModSecurity. We needed the source code for the dynamic module, or the module just in general. We happened to build it as dynamic, but we could have compiled it right into a version of Nginx that we wanted to use. But in order to do that, we needed to have the Nginx source code that matched the version that we're going to include this module into. And then we utilized the make modules command in order to actually build out that file. Now we're ready to go back into etc Nginx. And from here, we can utilize what we talked about before with the load module file directive and actually include ModSecurity into our configuration. So this is going to go into the nginx.conf because it needs to happen before we ever load the events and the HTTP. This is something that happens pretty early on in the process. And if you put it somewhere else, you'll run into errors. So that's kind of worth noting. We'll load ModSecurity dynamic module. And that's going to be load module. And then we need the path. And I'm going to use the absolute path from where we're at right now. And that's going to be etc Nginx modules. And then it was ngx _http _ ModSecurity module.so. And then we end it with a semicolon. So let's save this. Make sure we didn't have any errors and we're good. And now we need to enable ModSecurity using the ModSecurity directive that we'll have access to. And if we want to see how this works, we'll go and look at the example usage on the Spider Labs ModSecurity-Nginx. And these are the directives we're going to be working with. This is going to come inside of a server block. As you can see that there's a location right here. So there's a ModSecurity on-off option that we have here. So ModSecurity is not actually going to be used until we set it to on. And then the other one that we're going to use in particular is going to be the ModSecurity rules file, which takes a path for rules. This works kind of like include worked for us before, in a way, is that we could separate out the rules that we have for ModSecurity into a separate file so that we don't have to clutter up our location blocks with this sort of code right here. But the first thing we're going to need is the actual configuration itself. Thankfully, ModSecurity came with this, so we need to find a place to put it, and then we just need to copy it out of the ModSecurity repository. I'm going to make a directory in etc Nginx and just call it ModSecurity. And then from here, we're going to copy out of the opt ModSecurity directory, and then we'll get the ModSecurity conf dot or dash recommended, and we'll just call this etc Nginx ModSecurity. And then this will be ModSecurity.conf. Since the original recording of this lecture, there's been a modification to ModSecurity that actually causes an error with the recommended configuration, and we need to move another file over. So go ahead and run the copy command that you see on the screen right now to move over the unicode.mappings into the right spot so that you don't run into this issue. So we'll by default use the recommended configuration, but we do need to make one change to this file. So let's open that up, and I'll explain the change as we get to it. Within here, there's going to be an audit log that we can find. Search for audit. Yeah, so as we continue going through here, there's going to be audit log, and it goes to var log ModSecurity. Unfortunately, if we were to do this as is, we would run into another SE Linux error because we're not allowed to write to this directory from our actual web server. So what we're going to do here is we're going to change this so that it goes into the varlog nginx directory because we know that we're allowed to write into that particular directory. With that small change, we can save this and quit. And now we're ready to make this change to our default configuration to actually enable ModSecurity. And we'll put it into the SSL configuration since the HTTP version of our server doesn't do anything other than redirect. So we'll say ModSecurity on, and then ModSecurity rules file. This is going to be at etc nginx ModSecurity.conf, and then end with a semicolon. So that's a brand new directive that didn't exist in Nginx when we installed it. Our Nginx has been running this entire time. If we check our configuration, it's still working, and we should be able to reload Nginx and not have any errors. And we can check this with systemctl status Nginx. And it looks like it's still running. Let's make sure that we can actually access it. And it's working. We're not really going to worry about the in-depth nature of ModSecurity right now. We're going to talk about it a little bit later on. It has its own dedicated video in the security section of this course. But this video really covered what it's like to go through and build an additional module into the Nginx binary that you already have without recompiling the binary itself. We built it as a dynamic module, and we were able to include new functionality, utilize that in our configuration, and reload our running server without having any downtime, really. Welcome back to the Linux Academy Nginx Deep Dive. In this next section of the course, we're going to be talking about how we can utilize Nginx as a reverse proxy. But before we begin, I do want to define what a reverse proxy is and what makes it different than a proxy. So first, let's take a look at what a proxy server is. A proxy server sits between our clients and the internet. What that means is we would have our clients, which could be workstations, for instance, within our organization. They would route their traffic through a proxy server before it would make it to the internet. And this is often used inside of organizations as an intermediate layer for monitoring web traffic. A reverse proxy just kind of repositions where the internet is in that directional flow. So a reverse proxy sits between traffic coming from the internet and our servers. So it'll sit in between of a random request coming from somebody over the internet. And we can utilize this as a layer that will do load balancing, so we know which application is receiving the traffic, and also so we can serve static content from a cache and not ever need to make it to the end server. Keeping this definition in mind, when we move forward working with reverse proxies, we'll see how we can utilize it to improve the performance of our backend servers. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to continue working with the Node.js applications that we set up in the previous video to look at how we can proxy to these servers. This is a photo application, and we're going to set this up using the subdomain off of example.com of photos.example.com. And the main module that we're going to be working with today is going to be the HTTP proxy module. And this, along with two kind of companion modules that we're going to find for FastCGI and uWSGI, they all sort of have the exact same shape to them. If you kind of zoomed out and you squinted a little bit, you would see that they have roughly the exact same directives created for each of them. So we're gonna see that there's a lot of similarities here, and there are going to be things that we can do with each one of them that work almost exactly the same in the other ones. So I'm obviously not going to have time to go through and talk about every single thing we could do with the proxy module, nor the FastCGI module or the uWSGI one, but a lot of what we're going to be covering in each of them individually will be applicable to the others. When we first introduced reverse proxies, we mentioned that you could use them to direct traffic, doing some load balancing, and then you could also utilize them for caching. And we're going to do a couple different things. We want our Nginx service, so the actual Nginx server itself, is going to serve up static content because Nginx is fabulous at doing that. It is very, very performant at serving up data that it already knows, static content. That's what it can do. And then we can strategically have it route specific requests to our applications so that it can generate dynamic information, or that it can have the application handle the request and do what it needs to do, whether that be create something in the database or do some sort of calculation. It can do the dynamic work, but we can have Nginx sit in between so that our application server isn't inundated with requests and we're getting the most performance that we can. But when we're just going to set up the initial proxy server, proxy pass and the proxy pass kind of family of things here are going to be the directives that we're going to be working with. So this is going to be the main thing that we're working with right now, and then we're going to see how we can divide up some location blocks to serve different pieces of content without actually talking to the application. So the first thing that we're going to do is I'm inside of Etsy Nginx again. And from in here, we're going to create another file inside of our conf.d directory. And this is going to be for photos.example.com.conf. And this takes our standard server block that we've seen. That's going to listen on port 80. Whoops. And you could set this up with SSL if you wanted to with a self-signed certificate. That's just going to take a little bit of extra time. So we're not going to do that when we're just trying to demonstrate the fundamental features of a reverse proxy. But if you want to go that extra mile while you're following along, I encourage you to do that. And the server name is going to be photos.example.com. So now we get to think about what our location is actually going to do. We're going to set a base location block. And notice that we haven't set a route or anything yet, and that's because we aren't really serving everything from a directory. It's not like the static websites that we've been working with up to this point. We're going to be serving something that is a dynamic web application. Our web client happens to run on port 3000. So what we're going to do is we're going to set up a proxy pass. And then let's take a look at the documentation for proxy pass to see exactly how this is going to work. So proxy pass takes a URL. So that means it has to have an HTTP or HTTPS. That's one of the things about this. Proxy and the proxy module is going to be speaking HTTP. And our examples that we can see here are that it can be speaking HTTP to a server. So this is going to be something listening on a port. And this is going to require it to use its internal networking stack to kind of communicate, even though it's on the same machine. But you could also use a socket to speak to this, but you're still going to have to prefix it with your normal HTTP identifier in the beginning. And then you would just have another kind of prefix here that looks a little weird, but Unix : and then the path to the socket itself, and then you would have your kind of path to the URI. But most of the time when you're working with proxy pass, you're going to be using it just like this. You're going to have it with your HTTP or HTTPS, and then you're going to give it the URL that you want. For us, we're going to be working off of 127.0.0.1, and then we're going to give it the port for the application. So if we come back over here, that's going to be HTTP because it doesn't have its own SSL, and then 127.0.0.1, and then 3000. So technically, we could stop right there, and it would reroute the traffic that comes into the actual Nginx server to the server running on port 3000. But there are some other things we're going to kind of want to do around here. And these will cover common problems that we run into while we're using Nginx as a reverse proxy, or anything really as a reverse proxy. A lot of times in your applications, you're going to want to know kind of the IP address of the client, and you might need to know some other information, or you want to make some manipulation to headers. And so that's what we're going to kind of talk about right now. We're going to go back over into the documentation, and there are a few other things we want to look at. So proxy pass was one of them. The other one I want to look at is HTTP version. So proxy underscore HTTP version. And we want to upgrade this. So by default, it's going to use 1.0, but we're going to eventually be able to use keep alive connections. So for that, we're going to bump it to version 1.1. So we want to have proxy HTTP version 1.1. So that's another improvement we're going to make while we're working with our reverse proxy. But the other one, and to kind of cover that IP address example that I briefly mentioned, we're going to use the proxy underscore set underscore header. And this one takes a field and a value. And these are going to be the headers that we're defining or manipulating before we pass them to the server. So this isn't a response header, this is a request header that we're setting. And if you have an application that you're proxying traffic to that is expecting some very specific things in the headers, you can use your Nginx configuration as a place to add new information through headers or to modify things based off of the variables that we have in Nginx. So one of the standard ones, and to actually look at the entire chain of proxying that there could potentially be, is we can use proxy, set header, and then kind of a standard extra header. These are going to start with X's. It'll be X dash forwarded 4. And then Nginx provides us with a variable that is proxy add X forwarded 4. And what this will do, if we go look this up, is it will essentially create a string that is a chain of IP addresses starting with the real IP of the client and then going through the various IP addresses of the proxy servers that might have ended up in this. So it'll take the X forwarded 4 from the previous proxy and it will append its own information to that. And if there is no previous proxy, it'll just take the IP address that it had. We're going to set a field that is just the first part of that. That's going to be proxy set header. This is going to be X real IP. Then we'll set this to remote address or adder. A few other headers we're going to set here are going to be related to what would happen if we had this Node.js that was working with WebSockets. This is something that's kind of common if you're working with Node.js applications, as they occasionally work with WebSockets. And some of the things we could do there is there's going to be an upgrade header that we can set to HTTP upgrade. And then additionally, there's going to be a proxy set header of connection that we can just set to upgrade. There's really not any penalty to doing this. So if we have an application that we know might need to use WebSockets, this is one thing that we can kind of just do and feel okay about it here. So we're going to set these headers, and there's a lot of potential headers you can work with in HTTP, and there's not really a situation where we could cover all of them because not all of them are useful all the time, and it's something that is better to kind of gradually learn them as you go. But these are some common things you might look forward to, and specifically the X forwarded 4 is probably one of the biggest headaches that people run into when they start using Nginx as a reverse proxy, is they need to get the actual IP address of the client, and instead their logs on their application servers just repeatedly show the same IP address because they're seeing the IP address of their client, which is the proxy server itself. Let's save this, and we will check to make sure we didn't have any typos, and it looks like we're okay. Let's systemctl reload Nginx, and then we'll use curl once again with a header and a host of photos.example.com to localhost. And we get a 502. So 502s, this is going to be one of those things we run into fairly frequently. If we're using a system that is running SE Linux, this means that we have some sort of permissions error somewhere with Nginx. We can take a look at this by doing a less on var log Nginx error, then go into the bottom, And it looks like it is not allowed to connect to the upstream. So it's not allowed to use the network. And to get around this, we can use set se-bool. And then this will be httpd can network connect to be 1. Then we can try this again. So now if we curl, we see that it's actually going off and hitting something, and we don't exactly know what this looks like just yet because we haven't looked at it in the browser. But that's the next thing that we're going to cover. We've been using example.com domains because nobody really owns example.com, and it's one that's used for testing purposes like this. So what we have to do in order to actually go and look at a website that we're using example.com for is we're going to have to modify our Etsy host file. But we can't modify the Etsy host file of the actual server that we're on because we need to connect to it through a web browser. So what we actually have to do is we have to open up a terminal. And from here, we have to open up Etsy hosts. And we're just going to add it on to this list. And we need to grab the IP address that we have. So in this case, I'm going to look at my cloud server here. Copy this IP address. And we will paste that in here. We will paste this in here. And then we will set this to photo.example.com. And we'll save it. Now, if we come back to our browser and we try to go to photos.example.com, we can see that it actually went off and it did hit our Linux Academy Cloud Assessments demo application. One of the things that I like to make sure when we're looking at this is that everything actually went all right. So for that, we're going to look at inspect element. And in these developer tools here, the one that we really care about is going to be the network tab. So I like to open up network and then refresh the page so I can see all of the requests that are made and I can see what the status of those requests are. And I'm going to disable the cache just so it doesn't try to do that. And you can see that everything successfully got requested. Even this file select.js was picked up correctly, but that's one of those things that means that we routed traffic to our proxy server to serve a static asset that it was going to be using. Let's see what we can do to utilize the strengths of Nginx to not have to rely on the application server to serve up static content itself. So coming back to our web browser that is connected to our cloud server, we're going to go back into the configuration for our photos. And we're going to come down and add another location block. And this one is going to use a different type of matching that we haven't done thus far. And it's going to be a case-insensitive regular expression. So that's what if you see just the tilde by itself, that's a regular expression, but that is case sensitive. But if you see tilde with an asterisk by it, that means it's going to match on the regular expression, but it doesn't care if it's using capital or lowercase letters. So for this one, we want to match anything that has an actual period and then either JavaScript, CSS, PNG, JPEG, and that's the E is optional there, so we can put the question mark in there to say that. So that'll match JPG and JPEG. And then GIF. So this matches CSS files, JavaScript files, and the common image formats that we're going to see. And then we can go in here, and this is where we're going to set the root of just things that match this location block to var www photos.example.com. And we need to make this directory. So rather than making that directory new, what we're going to do is we're going to set up a symbolic link between srv www photo app apps web client, and then this is going to be the public directory. We're going to set this directory over to be var www photos.example.com. And now if we look inside of var www photos.example.com, we'll see that there's a JavaScript directory, and then inside of that, there would be that file select. We're going to go ahead and do a restore on the things inside of var www. And we'll make this verbose just because I'm kind of assuming we're going to run into issues. Oddly, nothing changed there. So let's reload Nginx. So we'll do systemctl reload Nginx. And then when we go and actually look in our web browser at our example application, make sure to check disable cache because we want to make sure it's trying to hit the right thing. And then when we go and do this, we're going to see that we're getting 403s for our file select file. And that means that it's attempting to use the new Nginx location block, but it's getting a 403. And these permission errors are undoubtedly almost always SE Linux in our experience. So if we go back over here, we might need to actually just add a new condition for our SRV wwws. And what we're going to do here is we're going to do se manage, then we'll make another file context. It's going to have a type of httpd sys content t. And then we'll just make this to where it'll basically work for any time there's a public directory inside of SRV www. So we'll set it to SRV www dot asterisk public, and then we will add an optional slash and anything trailing that, and then we'll end that string. So with that set up, we'll do the restore connection on SRV www, and we'll see what kind of change that makes. Goes off and makes a lot of modifications to things inside of there. And with any luck, when we go back over and take a look at this page, refreshing it, we see that we get all 200s. So that's kind of an indication to me that symbolic links didn't work exactly the way I wanted them to, but Nginx doesn't need to know that. Nginx just needs to know that it's looking inside of var www, so that's us being consistent across the various applications that we're working with. It's our job to understand the potential weirdness that you can run into with SE Linux. So now that we've successfully set up the reverse proxy, we can actually use this application, which we haven't done yet. Let's reopen that just to see if anything happens while we're using this. But the way it works is you browse to a file. I'm going to look inside my pictures directory, and I have a small file that I want to use. And I'm going to submit this. It went off and it uploaded the file and it actually grayscaled it. So we might have seen that it was an orange background before, and it went off and put it into S3, did some modifications to it, and then served that up directly. This, if we inspect this particular element itself, we can see that the URL here for the source is coming out of S3 directly. It's not actually being served up through Nginx. So this isn't actually putting any stress onto our server. This is what the photo storage application is going off and fetching. It's returning some information before our client application is building the HTML. But the other thing I wanted to kind of demonstrate is what happens if there is a larger file. So if we put a larger file in here, so this is something over a megabyte in size, and we submit this, we're going to see 413 request entity too large. So this is coming from Nginx itself. It's giving us a 413 error, which is kind of a weird one. But we have a request entity that is too large, just means we tried to submit a file that was a little bit too big. Since we had a sample application that was working with photos and that kind of larger piece of information, I figured this was a good time for us to talk about what can be sent to Nginx and how to get around this. Specifically, what we would do to fix this is we'll come up to the top of the documentation, and just to make it a little bit easier for us to find this, we'll look at the directives. But what we want is going to be the client max body size. And this, if we see here, is how we get around the 413 request entity too large. So we have to set this, and it's by default 1 megabyte. So if we want to set this to something else so we can accept larger images, then we're going to want to make a modification there. To do this, we're going to come in and modify our conf.d photos examples. And in this one, it goes just in the server block by itself. We can check to make sure that it can go in the HTTP section, the server, or the location. We're just going to put it in the server in its entirety here. And for this, we're going to have client max body size of, we'll just set it to 5 megabytes. and save. We'll reload Nginx. And then we will come back over into our page here. And we're going to try this again. So we'll browse to our large file, submit this. And now we can see that we have two different size pictures of my face, apparently. But we can handle larger files. So that is not actually related to us proxying applications, but it is something that we were uniquely suited to learn about while we were working with photos. So the client max body size is a good one to actually keep in mind. But if you're searching through the documentation, it's good to know what the HTTP status code is, because if it's very specific, then sometimes you can find helpful information about the directives that you're going to need in order to fix it by searching for that very specific number. Let's take one last look at our configuration for our photos. And the bulk of what we wanted to learn here was about proxy pass and the proxy module and the various things that we could do. We covered a couple of extra headers that you can send to the application if you need more information in the application itself. But the bulk of the way we are going to use proxy is going to be through proxy pass, HTTP, and then the destination server and port. And this could be on a completely different machine. You can do this through a private network if you have that set up. And then as long as it's something that can communicate HTTP, you'll be good to go in this particular proxy setup. In the next video, or in the next couple videos really, we're going to be looking at how we can proxy not speaking HTTP. We're going to use two different binary protocols. One is UWSGI and the other one is FastCGI. These are two protocols that are used with relatively common, actually extremely common web platforms such as PHP and Python, and UWSGI can work beyond just Python, but those are going to be our two examples, because speaking HTTP to our proxied applications is great, but doing this requires us to invoke the network stack. And so if we want to speak over a socket, sometimes it's better to just speak in a different protocol, even though Nginx is still going to speak HTTP to the end user. So that's something we're going to look at in the next handful of videos. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take the WordPress application that we set up in the previous video, and we're going to set up a virtual host server configuration for it so that we can use Nginx as a proxy for it, or reverse proxy rather. This is going to be using FastCGI, and we're going to be communicating over a socket, and we're going to be using a different module than we used previously. So before we used the Nginx HTTP proxy module, and now we're going to be using the Nginx HTTP FastCGI module. Notice the difference in what we see here when I click over to this next tab. There's almost no difference whatsoever. You can notice that it changes what's before the underscore, but basically all the rest of these directives stay the same. And that's how similar these two things are. Proxy pass and the proxy module are basically going to be speaking HTTP. The FastCGI module does almost all of the same things, except for it's speaking a different protocol in FastCGI. So if we know that these two modules are similar, then we can kind of assume that some of what we need to work with is going to be the same. So you'll notice that there is a FastCGI pass and a FastCGI pass header, and these are a little bit different than you would otherwise see. So we had the set header before on the proxy, but these are not exactly the same. So that's where the differences are going to kind of come in, and some of the things with headers, because since proxy pass and the entire proxy module is speaking HTTP, headers make sense. In the context of FastCGI, these are going to be parameters. We're going to talk about parameters quite a bit in a second. But proxy pass is going to take an address, notice not a URL. So this is going to be assuming that it's speaking not over HTTP, because FastCGI is its own protocol. But this is how we're going to actually be using it. It's going to be by using FastCGI pass with Unix : and then a path to the socket that we're going to communicate over. And this is more performant in a way because we are going to be bypassing the entire network stack and speaking directly over a socket. One of the other ones that we're going to be looking at kind of right away is going to be the FastCGI index. And the way this is going to kind of work is the same way that the index directive works when we're just normally working with Nginx for serving up web traffic, is that there's kind of a URL that it's going to be working off of, but in FastCGI context, that's going to be the script file name. And we need to kind of know what is going to be put beyond there if somebody sends over something that isn't a specific file name. So if somebody sends a slash, we want this to be index.php, probably. So we actually need to set this, and we're going to set this one too. Let's get started just knowing that we need to use fastCGI pass and fastCGI index. We're going to get started by modifying a new file called confd blog.example.com.conf. Takes a server block. It's going to listen on port 80 with a server name of blog.example.com. And then we're going to set the root here because remember, we put the entire WordPress application into var www, and we did that because that's kind of the standard thing you do with PHP applications like this. So we're going to do that into var www blog.example.com as the root to serve static files from. And then we're going to set up a location / directive that's going to have a few different try files in it. Woo. And inside of here, what it's going to do is actually do try files, and it's going to look for the URI itself. So if somebody makes a request to a static file that we have, it's going to go ahead and accept that. If that doesn't work, it's going to look to see if there's a directory for it. And then next, we want it to go to index.php and then pass on the arguments as a query string. So if we can't actually find the URL and it doesn't end in PHP, then we're going to assume that it's going to be kind of a search parameter for us. We're going to change the actual index to be index.php. And that's so that if there's an index.html, we don't just try to serve that up. We're always assuming that we're going to be serving up from PHP pages. To get past this, now we're going to go and create another location block that's going to take a regular expression for anything that ends in .php. Oops, sorry, that's a $sign, not a question mark. And then here's where we're actually going to set up our reverse proxy. So the first thing we're going to do is set that fastCGI index to be index.php. And then we want to do a fastCGI pass. And remember, this takes an address that can be a Unix socket. So we're going to do Unix var run php fpm.sock. And then the thing that we haven't seen up to this point that is you're going to see quite often when you're working with PHP FPM and fastCGI things in general is going to be this line that is, not induce, include fastCGI params. And we'll take a look at that file, but this is a file that comes default with your installation of Nginx. And one extra thing that we need to do because we're working with WordPress is actually going to be changing a parameter that's already set in there for script file name. And this is going to be document root and fastCGI script name. So let's save this. And then we're going to open up, and since we're local to these files, we're going to just open up another file that is fastCGI params just to see what this is. And you'll see that it calls fastCGI param numerous times. And remember when we were talking about what this was, and fastCGI being its own binary protocol, where HTTP has headers that it can speak, fastCGI has its own params that have very specific names, and then we want them to be very specific values. So this file is Nginx's standard way of converting what it knows how to speak over HTTP into the proper names for fastCGI so that it can pass those over the socket or just through the fastCGI protocol to another application that can speak fastCGI. What we did by adding the script file name param was make one that isn't in here. So there's currently no script file name param, and that's just because there's a difference in the newness of the PHP that we're using and this configuration that comes out of the box, where we needed to make a slight modification with how standard PHP is configured, so we needed to add that. But thankfully, this is basically what you need to have set up, and this is how you would customize, kind of in place of headers, this is how you would customize information that you're passing over the fastCGI protocol is by adding another param. So we can use bn to go back to our previous buffer. Since we already have this fastCGI params file that's setting up the mapping, it's really the adapter layer between these two things. This basically gets us where we want to go. So now we're ready to save this file and quit And then we want to make sure we didn't mess anything up and use systemctl reload nginx. And we need to go into our Etsy host again. Oh, whoops. Not on the cloud server, though. That's important. We need to come over here and use sudo to vim into Etsy hosts. And we're going to add blog.example.com to the end of this list and save it. Now I can come back over to Firefox and use blog.example.com. This is going through and letting us configure WordPress because it's the first time we've actually done this. We're going to set this up as a test blog. And username, I'm going to use just admin. And I'm going to change this password to be password. Hopefully it'll actually let me do that. There we go. And that's just because this isn't a real website, but I want to make sure that I don't forget the password in between recording videos. Send this to my Linux Academy email. And discourage search engine. Not that it could actually find this, but now we can have it install. And we can log into our admin dashboard. And we have a running WordPress blog behind Nginx. Going back and taking one last look at our configuration, if we look at the blog.example.com.conf, I just want to kind of call your attention to similarities and differences between what we did with Proxy Pass versus Fast CGI Pass. And so you can kind of get the visual mapping of how these things would work depending on the kind of application that you're trying to proxy to. They're mostly the same concepts. It's just instead of headers, we're going to be using params pretty often when we're working with Fast CGI and also when we're working with uWSGI. So I encourage you to go ahead and take a look at the documentation and kind of compare and contrast what's going on between the proxy module and the Fast CGI module and become familiar with these. These are going to be things that you're going to be using a lot with Nginx because reverse proxying with Nginx is one of the most common things that we're going to do with it. In the next two videos, we're going to set up a uWSGI Python application, and then we're going to set it up to use uWSGI's module in order to proxy using the uWSGI binary protocol. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at our last type of proxying that we're going to be doing, and that's going to be using the uWSGI binary protocol. And we're going to be using a sample application that I wrote a couple days ago for just communicating with uWSGI. It's going to be a Django 2 application that's going to use Python 3.6, but we're going to use MariaDB because we already had it installed. So this video is going to take us through setting up this application. And a lot of it's already automated, but if you want to poke around and see how this is kind of done, most of it's in a makefile or a couple other scripts. But the first thing that we're going to need is actually going to be this URL. And then we can come over and we're going to put this into srv www. And then we'll do git clone and then content uWSGI. So we're going to need Python 3 installed. So I currently don't have Python 3 installed. So we're going to install this using yum install Python 3.6 and Python 3.6 devel. We're expecting there to be a pip installed, but we don't have a pip3 installed yet. So we're going to go ahead and do that using the bootstrapping script that they provide to us. So we'll use wget https://bootstrap.pypa.io/get-pip.py. And then we'll do Python 3.6 to get pip. And this will go and install pip, which is one of the Python package managers that we can use. It's really just a tool installer, but yeah, we can get that in there, and then we can also remove this get pip from within our directory. But we need a couple of things installed before we can actually run through and do a lot of the automated stuff that we're going to be using with this Django 2 application. So we'll do pip 3.6 install pipenv, which is another tool for managing projects, and requests. With these dependencies installed, we're ready to actually cd into the application. And we do need to create a user in our database. So we're going to do mysql-u root, and then it's going to ask for our root password again. And we're going to do basically the same thing we did before, except for now we just need to set something up specific for our notes application. So we're going to use create database, and this is going to be called Django Notes, and then grant all privileges on Django Notes .star to notes at localhost identified by, and then we're going to actually use the same password. This isn't how you would do it really in real life, but I like having simple passwords for examples. And then we will once again flush the privileges. And now we can quit out. So we need to remember that Django Notes is the name of the database, Notes is the name of our user, and our password is password with an @ and a 0. So if we take a look at the makefile, we can actually look at what is going on here, but we can see what we have. We need to migrate a database. This install one is going to actually go and install all of our dependencies, so we're going to want to do that one first. We're going to migrate the database. We're going to want to generate static assets for ourselves, and then we're going to use make service, which will go and automate all of the setup of the service file that we're going to need in order to run this on the start of the system booting. So let's get started by using make install. Actually running make migrate is going to require us to set up some environment variables. So if we take a look at the README for this, it's going to tell you that these are the various make things that we can use. But for make migrate, which apparently I used to call DB init, we're going to need notesdb, notesdb user, and notesdb password. And the host and port are going to be localhost and 3306 because those are the defaults. So it's completely fine for us to be able to work with those right now. So we need to go and set notesdb, notesdb user, and notesdb password before we actually do anything else. So we'll use export notesdb. Oh, it's not showing my underscores because I'm too low. Export notesdb. This is going to be Django Notes. Export notesdb user. Going to be notes. And export notesdb password is going to be p at ssw0ord. And now we can do make migrate. Now we want to run make static. And what this did was it actually went and created a directory at notes.example.com. This is the default. If you wanted to set a different host for this, then you could modify that, but it's going to put it in var www notesexample.com/static, and this is where it's going to request static content to be served. The actual Python application won't even try to serve static assets. The very last thing we need to run is going to be make service, and this is going to ask us for our host, which is going to be notes.example.com. Database name, Django Notes. Database user of notes and password. And then if we go and we actually take a look at what's going on inside of etc systemd system, there's now a notes uWSGI service that has everything kind of set up that it needs to, and all of the particular commands that it's going to have to run in order to do this. So the last thing we're going to do is going to be systemctl start notes.uWSGI, and then systemctl enable notes.uWSGI. In the next video, we're going to go through and set up a virtual host for this for notes.example.com that will actually proxy over uWSGI to our application. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at proxying to our uWSGI application using the Nginx HTTP uWSGI module. If we compare just the general shape of this once again to the fastCGI and proxy modules, you'll notice that once again, they all kind of meet the same pattern and have a lot of the same interface to them with the actual directives that they supply us with. So you can expect this to work a lot like the fastCGI version of this. That would kind of indicate to us that one of the things we know we're going to use is going to be the uWSGI pass. And indeed, this is going to work kind of the same way. So we can send it an address, and you can give it an optional protocol. It can have a couple of different ones that you can use. We are once again, though, going to be using a socket because it's kind of just advantageous for us to do so. And another one of the things that we can kind of expect there to be is going to be uWSGI params. So there is, once again, a uWSGI param directive, and it also has a provided uWSGI params file that we're going to take a look at before we actually finish this. But there's not a whole lot that we need to do that's different than what we've seen before. In fact, nothing is different than what we've seen in the fastCGI version, so it's going to be pretty quick for us to get this up and running. We're going to go into the etc nginx confd directory and create a notes.example.com.conf with a server that listens on port 80, server name of notes.example.com. And then the one thing that is going to be a little bit different is we knew when we went through our setup process that we had the make static command that moves any kind of static assets that it needed to into a directory inside of var www.notes.example.com. So we're going to have that as our root, but we can actually set this up to only really care about that as the root if somebody sends us a request that is to /static something else. And that's where all of the static asset requests are going to go in our application. So if we create this here, we can set up the root to be var www.notes.example.com inside of this one location block. And then our next location block is going to be the standard root location block where we actually set up our proxy. So here we're going to use, include uWSGI params, and then uWSGI pass to Unix. And this is going to be at var run uWSGI notes.sock. And this is just something very specific that in our services file, which we can take a look at here in etc systemd, system notes, we can see that we actually set it up to have a very specific directory here. And then in the uWSGI configuration, that is this uWSGI ini, it is saying that that's going to be the socket file that it uses. So if we switch back to our configuration here, we can just rely on that's where we want this to be. And the reason we set it up to be within the uWSGI there is just so we could kind of group those together if we wanted to. If we had multiple Python applications or just WSGI applications running and we wanted to put their sockets in the same directory, we could go ahead and do that. Let's take a look while we're here at the uWSGI params file that's local to us. And you can see that this works in almost exactly the same way as the fastCGI params file. The difference here being that there's not a bunch of PHP specific things, but it's still just a mapping of what Nginx knows how to speak and what the parameter is expected to be inside of the uWSGI protocol. You will notice that we were talking about that remote address thing when we were doing the proxy pass, and we're not doing that right now, and that's because inside of the protocol itself, that already exists. So similar to how we were sending the X real IP header for proxy pass, we're using remote address here. But we're not going to need to make any modifications to these particular parameters. So we'll switch back. And this is actually going to be our final configuration file. So let's go ahead and save and quit. Make sure we didn't make any typos. Reload Nginx. And then we need to jump back over into our separate terminal so that we can modify our local etc host file. And add yet another subdomain here, so notes.example.com. And now we can come back and open a new tab to see if we can get to this site. The infamous 502 bad gateway error. SE Linux once again has a security issue with what we're trying to do. And we've kind of gotten to the point now where just adding individual lines using SE manage and the file context is kind of becoming a little bit tedious. So let's go ahead and create our own policy file for Nginx. This course is by no means about SE Linux, but one of the most common things you'll find if you search the internet for this is going to be to just create a file that permits the things you know you're trying to do with Nginx. And we can do this by grepping for Nginx within var log audit log. And then we can pass this to audit to allow with a small m and an Nginx, and this will show us what the file would kind of look like. And so right here, we can see that there are quite a few things that it's kind of expecting that we should be able to do. And we apparently need to restore some of the permissions to various things inside of our system. But the one that it's giving us a problem on right now is going to be inside of the uWSGI notes.sock. We didn't have it permitted to do a Unix stream socket. So this is what it's going to need to do. And what we can do here is, in place of the lowercase m that we just used, we can use an uppercase m. This will generate a file for us that is nginx.pp, and there's also another one that is nginx.te, but we're going to use semodule-i nginx.pp. And this will load in this new policy file that it's generated based off of all of the errors that it's seen in the audit log for Nginx. And since we've been using this privately and nobody else has been messing with it, we know that everything we attempted to do, we were attempting to do because we thought it was valid. So we saw these errors. We don't really think they should be errors. It's fine for us to put these into a policy file that we can load in. And then we're going to do an SE module enable Nginx. If we take a look again at the nginx.pp file, oh, that's the binary version. If we look at the TE file, that's going to be the non-binary version of this, but we can still see here that it's expecting us to go through and do a restore con on some things. So before we can actually proceed, we're going to need to do this in both. I'm going to just do it on var ww as a whole and the var run area. So let's do restore con rv on var www example.com and then restore con rv on run uWSGI. Oops, forgot a slash there. With our security issues hopefully figured out, if we go back over and we check out this page one more time, we should now see an actual application here. And if we pull up inspect element and load our network tab again, and we refresh the page, you can see that we have quite a few different things being pulled in here, and most of them are actually coming from our domain, which this is all being served statically, which is Nginx doing what it's supposed to be doing. And we can sign up and create a user, take my user name here, and then finish our sign up process. And now we can go in and create a note. And this is a test note that can do syntax highlighting for us. So if we wanted to create a server block, we could do that inside of our actual notes. So if we wanted to create some snippets, we could go ahead and do that in here. And then you can see them with syntax highlighting. So simple application that we have running, but it's an actual application that's not just doing hello world business back there. Some of it is going to be dynamic user created content, and some of it is going to be more just static content that we have. So now we know how to proxy using quite a few different protocols. So if we take a look one more time at the notes.example.com, this is our uWSGI pass proxying using the uWSGI params also. And this is our simplest version that we kind of came up with, just kind of using the defaults here. But when we talked about what a reverse proxy was, it was more than just one thing, right? It's a server that sits in between internet traffic and your backend application servers, but it can be used to do quite a few different things. And thus far, we've used it to route traffic to the right socket or to ports that aren't publicly exposed in the case of our proxy pass. And then we've also used it to serve up static content so that our application servers don't have to manage those separate requests themselves. In the next couple videos, we're going to take a look at how you can also use a reverse proxy server as a cache server and how proxy fastCGI and the UWSGI modules, all of them give us access to various caching techniques that we can do. So we're going to cover having some caching set up and what kind of headers we'll work with, and then also the concept of micro-caching. Welcome back to the Linux Academy Nginx Deep Dive. We've talked about setting up proxy servers, or reverse proxy servers rather, with Nginx. And now we're going to look at how we can utilize our reverse proxy to also do some caching so that if we know what the response is going to be from a server, we can serve up that content without ever needing to bother our application server with yet another request. So this allows us to, once again, exercise something that Nginx is very good at and also eke out some more performance from the application servers that we have because they're not going to be answering the same requests over and over again. And this can be really good, obviously, if you are experiencing a lot of load. Like Nginx can handle a lot of requests simultaneously versus something like a application server that's using Ruby on Rails or Django maybe. They can handle less, right? Nginx is written in C, it's highly performant, and it's optimized to handle a lot of requests versus something that's running Python, PHP, or Ruby is going to be, there so that the programmer can write something to handle some sort of situation, but inevitably those are less performant than what Nginx is going to be at just serving some bit of content. So once Nginx knows what to serve for a specific URL or a cache key, as we're going to find out here in a second, then it can serve that up rather quickly and prevent you from needing to go and scale out your servers and have a ton of application servers in order to withstand the load that you're going to get. We've talked about it numerous times up to this point, but the proxy module and the fastCGI module and the UWSGI module, they all pretty much work the same way, and they have a lot of the same cache attributes here. So we're going to be working with this cache, and for the caching segment we're going to do right now, we're actually going to use the fastCGI cache and work with our blog that we already have because WordPress does some things that makes it easy for us to see different interactions with content. But you could do all of these same things using a proxy pass setup that you could do with fastCGI. So everything we're doing here, for the most part, you can just substitute fastCGI for proxy and it will work the same way, or UWSGI. But WordPress just happens to be a good example for us to kind of look at the benefits we can get out of caching. So let's go ahead and get started now. There are a few things we need at first. So proxy cache is going to be the kind of the main one. And if we look at this, it's going to request a zone. And a zone is a shared memory used for caching, which what this really means is it wants you to have a named cache on disk. And this is where we're going to run into the cache path. So if we look at fastCGI _cache _path, this will be actually how we define what our cache is going to be. And there are a lot of options that we can get through here. So we're going to create one that's going to be for our blog, and it's going to go into the var cache directory. And we'll go through not using all of these because unfortunately, some of these things like the purger, these are parts of Nginx Plus that we don't actually have access to, even though they're here. But for the keys that we're actually going to be using, we'll talk about them as we write it out. Let's go ahead and modify our confd blog.example.conf. And one thing to note is if we go back and take a look at the cache path, you'll see that it needs to be in the HTTP context, which means it's not going to be inside of our server block. So for that, we're going to go to the top of the file, and we're going to do fastCGI cache path. And then I'm going to go ahead and put a new line there and kind of break this out a little bit. But if we look at this, the first thing we need is a path, and then there are going to be a bunch of different options. But you'll notice that these with the square brackets are going to be optional, but then there are some still that are required. So key, zone, and name is going to be the one that's required, and everything else is optional. We're going to put them in this sort of same order, though. So we're going to do a levels after our path, and then we're going to put a key zone in here. So ours is going to go to var cache nginx blog, and then the levels. This one is a little weird, and you're always going to see the same configuration for this. In all of my searching and looking into the research that I did for, really understanding Nginx myself, this is what I found every single time. And what this levels key does is it sets how many subdirectories should be used in order to store things. So the way that the cache kind of works is Nginx in memory is going to have a hash table that it can use key values to look up, and it's going to save keys that are based off of the request that you're sending, and then the value is going to be the destination on disk where the information that it needs to respond with is going to be stored at. And if you have a bunch of files in one directory, it can be kind of hard to look through those things, but if you use subdirectories for things, then it is actually a little bit faster for Nginx to look those up. So we're always going to set this to be levels equal 1:2, which will set it to be a 2 subdirectory path style that it's going to use, and that's going to be underneath blog. So you'll see various things. It'll be like blog/c/12345/ and then some piece of content. We're going to spread this out onto a couple different lines here, but we're going to go with keys zone, and this is going to be the name. So we're going to call this blog, and then we're going to say any of the keys can be up to, it's going to be within blog, and then the size is going to be 10 megabytes for us. The total size of the cache, which is going to be max size, it's going to be 1 gigabyte, and then anything past 1 gigabyte, we want to start deleting things from the cache. And Nginx can do that already, and it'll know what to remove. And then we're going to set one more that is going to be inactive equals 60 minutes. And that just means that after 60 minutes of not being accessed, we're going to remove bits from the cache. So this is configuration of how the cache itself is going to work. And then we also have to, in the same area where we're doing our proxy setup, we have to configure how the actual cache is going to work with relation to our proxy. So let's move down a little bit. And one thing we can set, and we're going to set it inside our server block here, is going to be fast CGI cache key. And this is going to be scheme request method. So whether it's a post, get, host, request URI. And this is an exception to what I had said before about the similarities between fast CGI and proxy. And the reason for that, if we look at the proxy cache key, is going to be that it has a default that is the actual request. The difference here being that when we are proxying something to a application speaking a different binary protocol, is that it's not going to default to that same kind of HTTP path sort of thing. So we actually do need to manually set these. So this is going to be at fast CGI cache key. And you'll notice that there is no default in this context, so we have to do it ourselves. But by combining enough of the variables, we can make something that uniquely identifies any request that comes to our system. So the one that we've created here with the scheme, whether it was HTTP or HTTPS, the request method, the host, and the request URI, which is essentially the domain and the URL, this is sufficiently specific to what we need to do, because the only real difference here would be if somebody was trying to send a post or a patch for a create or an update. If this were a RESTful system, you wouldn't want to cache those anyway, because you really only want to cache get or head requests for the most part, because that's reading data, which is less likely to change than if somebody is actually posting something where they should be modifying or creating something within the system. Moving on, we're going to go down into our location block with our actual fast CGI setup here. And we're going to do fast CGI cache, which takes a name. So this is, we had to define it with cache path up top, and now we can do blog. And then the next one we're going to add here is going to be fast CGI cache valid for 60 minutes. And the cache valid bit here is really one of the areas that you can fine tune the performance of your application in the cache. If you make this really, really long, then that means it's going to be hard for you to update the information on your site. But if you make it really, really small, then you're going to have more requests going through to your application. What you can do to kind of really get this right for the application that you're working with is you can kind of sync this up with how long it takes for your content to be updated or for you to push out changes to your application. So if you know that you only deploy once a day and that no dynamic content is created, then you could have your cache be valid for an entire day. And then every time when you deploy, you could just wipe out your cache. And then the first request that is made would be the only request for each individual piece of content that your application can serve up until the next day when you have probably done a deployment. So we're going to look at cache valid more in the next video when we talk about micro-caching, but you can realize that this is where you're going to do a lot of the tuning for whether or not you should cache things for long periods of time or short periods of time. And I like to sync these up with the inactive, remove it for 60 minutes, or it's cache valid for 60 minutes. This kind of just ensures that after an hour, something is going to be removed. So let's save this configuration and make sure we didn't mess anything up. reload Nginx. If we head back and we take a look at our inspector here, let's go to the network tab. Make sure that disable cache is no longer checked if it was still checked for you. I know sometimes these things can stick around longer than you expect them to, and it makes it weird to debug things. But the next thing we're going to take a look at is going to be actually going to blog.example.com, and ensuring that we're not signed in. And yeah, as you can see here, I am signed in as admin. And if we refresh the page one more time, we're going to see this request that's a get for /, and this just means this is the actual kind of body itself. And if we click it, we can see headers. And this is really, really useful information to us. So this is good for debugging things, but you can see that there's a response header of cache control, no cache, must revalidate max age. And what this means is that the WordPress application sent this header back to Nginx. This is the header that Nginx looks at to know whether or not it should write something out to disk. And in this particular case, it's not going to do that. And the reason that WordPress sent this was because we were logged in. This makes it dynamic at this point because these are changing things up here. And so it's not just static content. If somebody had made this same request, but they weren't logged in, then WordPress would have skipped adding this header and Nginx would have cached it. If we look in var cache Nginx blog, we can see that there's nothing there. That's because it didn't actually cache any things. So what we're going to do now is we're going to go and, not actually go into the admin panel. We're going to go and we're going to log out. And we're going to visit the website again. And we're going to see if there's any difference. So now if we click on this, you can see that the response headers don't show that cache control header of no cache anymore. And you'll see that our response time was 434 milliseconds. And if we refresh the page, you'll see that it went from 443 down to 293. But is that because it cached? And one way we can check this is by looking inside of the blog directory, and now you can see that it generated some subdirectories. So that means that Nginx wrote something to the cache. But unfortunately, knowing the timing difference here isn't a great way for us to actually go about testing our caching. So the next thing we're going to do is we're actually going to manually add a response header for ourselves by editing our blog conf here. And we're going to use a new one that we haven't seen yet. It's going to be add header. And this allows us to add a response header from Nginx itself, not necessarily from the side of the application server. And we're going to call this x-cache-status. And then we're going to return the variable of upstream underscore cache underscore status. And if we check to make sure there are no syntax errors there, and I realized now actually that I closed that kind of fast. Sorry about that. But yeah, so we're adding a custom X header here. That's x-cache-status. You could really call this whatever you want. This is just one that I've used in the past. And then this variable of upstream cache status is going to be really useful to us so that we can see whether or not it was a hit, a miss, or if there was some sort of issue. So with that line added, we'll save and quit, and we will reload Nginx. And now if we come back over here and we refresh the page, we can see that we have an X cache status here of a hit. And that means that we've seen this page before, and it was actually already in the cache, so it didn't ever need to make the request go all the way over to our application. If we go and look at a specific post, the first time we hit this post, it's going to take quite a bit longer. We're going to see X cache status miss, and then we're going to know that if we hit this exact same page again, that we should get a hit, because the second time around it was already cached. It's going to be cached for an hour in our context. And so this is really good for us. So WordPress is pretty smart about knowing what it can cache and what it can't cache based on whether or not we're logged in. And one of those things would be if we just go to WP admin. This is an admin dashboard. If we take a look at this response, you'll see that for this particular form, it actually doesn't care. But if we sign in, apparently typed my password wrong. When we actually sign in and we're looking at this page, you'll see that once we're in WP admin, we're getting no cache, must revalidate. And that's because it knows that everything inside this area back here is going to be dynamic. It's going to be from us writing our own posts, creating our own pages. So the application itself is smart enough to report back whether or not this content is cacheable. And if you are working with applications where the developers have already written out these proper response headers, then that's great. Then you're fine and you don't really have to worry about this too much. But if you know there are certain situations when you don't want to cache things, but the response headers aren't actually being set by the application that you're proxying to, then we're going to look at how we can manually decide whether or not we want to cache these things. And this gives us a good opportunity to take a look at setting our own custom variables using conditionals and also the other cache directives that we have access to that can tell it to manually bypass caching. So we're going to open up our configuration again. And like I said, we're going to use a custom variable. And we're going to do this using the set directive. And then variables in Nginx start with a $. We're going to call this skip cache. And then we're going to set it by default to be 0. And that 0 is going to be important when we look at the documentation for the actual no cache directive that we're going to be using. But the next thing we want to do is we want to use an if statement, which takes a conditional in here, which in our case is going to be request URI if it roughly matches the string of WP admin. And by roughly matches, I mean that's a case insensitive search. So if it's WP admin or capital WP admin, then if this matches, then what we're going to do again is we're going to say set skip cache to 1, and then we're going to continue on. And then inside of our location block, where we're actually configuring all of our cache interactions, we're going to use a couple different things here. We're going to have the fast CGI cache bypass, and that's going to be the value of skip cache. And then the flip side of this is going to be the no cache skip cache. And what this means is that if there is something in the cache, we're going to go past it and not actually serve what's in the cache. And then when we get the response back, regardless of what the PHP application says, we're not going to cache it. So using this conditional, or using this variable rather, and with this conditional to set it based on our location, we're able to explicitly not cache the content and go right past any potentially cached content that there might be. So let's save this. Make sure we didn't have any problems here. And we can't really, in this case, test it because the WP admin area is already telling it not to cache itself. But if we go and we look at the documentation for this, we can go and look at cache bypass. And you'll see that it takes a string, and if the string is not equal to 0, then whatever is going on, like, it won't be taken from the cache. So it's going to go right past the cache and not actually pay attention to it. And then similarly, if we go to the no_cache directive, it's going to take a string, and if it's not equal to 0, then it won't be saved. So those two things allowed us to explicitly bypass the caching. There are more tweaks that you could potentially make to a cache, but for right now, this is kind of the basics of how you can create a cache and get one spun up and understand what's going on there. But once again, if we look at the documentation and we just go up to the top of this page, we can see that there are quite a few different cache options that we have. Some of them, unfortunately, are not going to be accessible unless you're using Nginx Plus. So this cache purge is a really awesome feature that allows you to set up some mappings. So if somebody sends a purge request, like that would be the actual HTTP verb type, you could actually clear specific parts of the cache, but you'll notice that it says this functionality is available only as part of the commercial subscription. So this is an Nginx Plus feature only. And unfortunately, it shows up in the nginx.org documentation so that you know it exists, but we don't have access to it since we're not using Nginx Plus right now. But the caching that we're doing right now is one means of caching static content that's really not dynamic, and we looked at how not to cache some content. In the next video, we're going to take a look at how we can get past the cache invalidation problem, because that's really one of the hard things to deal with computers, is knowing when not to cache things or when to break the cache, by setting an extremely short cache time and doing what is called microcaching. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at how to use microcaching, which is short-term caching, in order to improve the performance on applications that might have rather dynamic content, but is not going to be updated every millisecond. It's something where you can have caching for a very short amount of time, but if you're under an extreme amount of load, you can actually get a lot more performance out of Nginx and a lot more performance out of your application server by using this trick known as microcaching. So to demonstrate this, we're actually going to utilize a load testing tool called Boom, and then we're going to be working with the uWSGI application. Once again, what we're doing right here could totally apply to using the proxy pass stat type of proxying or the fast CGI proxying, but in this particular case, I wanted to show it with the uWSGI application. The first thing we're going to do is we're going to pip install Boom. And we're going to want to make a request to notes.example.com. And we're going to do this so that we're using 30 concurrent users and making 3,000 requests. And then we're going to do a compare and contrast on what happens when we do that to the server right now versus what happens when we do this to the server with microcaching enabled. So to do this, we're going to use Boom. And then this is going to go to localhost. Then we need to pass a header. And this is going to look a little weird because we don't pass it in the normal string. So it's going to be host:/notes.example.com. And there's no space in between the colon and notes like it was when we were passing this to curl. So that's one thing to notice. And then C for concurrent. So it's going to be 30 concurrent. And then we're going to do 3,000 total requests. This is quite a few requests, and it's taking quite a while. Granted, we're working on a relatively small server, and we only have one instance of this application running. uWSGI is going to be running a couple different processes, so we have the equivalent of roughly 2 different Python processes that would be handling these things. But we can see that it took 15 seconds to do 3,000 requests, and it has requests per second of about 190, which is pretty good, all things considered. Which is what it tells you right here. The Boom speed index it thinks that what we did there was pretty good, but I think we can do a lot better. And we're going to use microcaching to get that done. All of the directives that we're going to use inside of our notes are going to be the equivalent that we've already seen. So we're not going to see any new directives. We're just going to use them in a slightly different way. So we're going to use the uWSGI version of all these things, but it's going to be cache path. And then we're going to call this var cache nginx, and this is going to go micro. It's going to have that exact same levels, :1, 2. And then the keys zone is going to be micro with 10 megabytes with a max size of 1 gigabyte. And we're not going to set an invalid because it would never make it that far with what we're going to actually be doing. We're going to set a uWSGI cache key. And this is once again going to be scheme, request method, host, and request URI. And then when we go down into our main location, this is where we're going to add our caching. We're going to add the add header x cache status. So we can manually test this ourselves with upstream cache status. And then for the caching side of things, we're only going to set 2 of these. We're going to set the uWSGI cache, which is going to be micro, which is the name we set up above. And then the other one is going to be uWSGI cache valid. Whoops, need an underscore there. And then this is going to be 10 seconds. So this is the big difference. This is the difference between the caching we did previously with the static content that we knew wasn't going to be changing and the relatively dynamic content that we're going to have on this notes site. Specifically, the notes landing page pulls in the most recent note that any user in the system has created and just demonstrates its name. It'll say, oh, this person wrote this note. So that means that it could update itself pretty frequently, but we want that to be relatively up to date for the people who come to our site. But if we get a lot of requests within a short amount of time, then we only want to make one of those requests. Specifically, this is going to have us making one request to a single key, so a single page, every 10 seconds. And then after 10 seconds, we're going to be making a new request again. but every other request within that 10 seconds for the exact same page is going to be served out of the cache. And this is allowing us to essentially invalidate the cache every single 10-second interval and still serve semi-dynamic content in that case. So it'll seem like it's almost not cached. But let's save this. No more talking. We're going to make sure we didn't type anything wrong there. So we need to systemctl reload nginx. And now we're going to push up a few times till we get to that boom line again. And we're going to run this. And as you can see, it's flying through what's going on here. So that's telling us already that we're handling these requests quite a bit faster. So we did 3,000 and it took us 6 seconds. Remember that before it took us, 15 seconds? But this time around, it took us 6 seconds. So it did 190 requests per second before, which is this RPS. We just did 446. So we were only caching for a 10-second period, but even doing that minimal amount of caching, we got a huge performance gain out of this. And if we go and we actually take a look at here, we'll do it this way. Go back to our network tab. And if we do notes.example.com, we can see that it directed me right into this page. And that is going to be a cache miss. I took quite a while to get back to this. It's going to be a cache hit. But if I wait and wait and wait and wait a little bit more, and I reload this page, we're going to see that the cache had expired for this exact same thing. If I refresh again, you're going to see that it was a cache hit because when I hit it and it had expired, then that was me refilling the cache for another 10-second period. So this is a video about kind of an obscure topic, but it's just looking at what it can mean to really modify the configuration of your cache to get a little bit of extra performance out of it with something where people are, this Notes platform is essentially kind of like a Twitter in a way, right? Like you could go and you can make new posts that would show up. And so since you have dynamic content from users, then that's one of those situations where you can't really cache things all the time, but that doesn't mean that you can't cache things for a short amount of time if it's okay for you to wait a few seconds before somebody actually sees a piece of content. We more than doubled our requests per second, which means that we had we had that much more time to be able to handle normal requests that are coming through, or even a higher load than what we're actually used to before we really need to scale out our servers, because we can just rely on Nginx to serve up a lot of content from the cache. And if we really wanted to test this even further, we could just change the concurrency level of what we have. So we have 30 currently. I have no idea what it's going to do if we change it to 50, but it's going to go and churn through these things. And it's still going relatively fast. So we'll see what kind of... It still only took 6 seconds. So the response per second was still, about the same here, even though the concurrent users was even higher. So we still were gaining a lot of performance there. You could handle a lot of requests for this. So that's microcaching. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look into logging a little bit more, and we're going to do that by covering how access logging works, what we can do with log formats, and how error logging works. To get started with this, we're going to go into the etc nginx nginx.conf, which we've looked in here before when we first started this course, and there were a couple lines in here that related to logging. In fact, all 3 of the directives that we're going to talk about are already in here. And so we want to get a better understanding of what exactly these do. The first one we're going to talk about is going to be log format. And log format and access log, the directive used right underneath it, both come from the HTTP log module. And there are not very many log modules directives. So log format allows us to actually go and create a named format. And that's what this first portion is. So compression in this example would be the name of a format. And then this string, and when you're separating it here, so they just go to another line and then it will concatenate those itself. But this string is the information that would be represented if somebody used that as their access logging format. The format has nothing to do with error logging, so that is one thing to note. And what we already have pre-existing for every one of the servers that we've got is the main format here. And that has this set up. And quite a few of these variables we've seen, and some of them we haven't, but they're pretty self-explanatory in terms of what they do. And the way you go about setting a logging type is through access log for using this sort of thing where we have a format to it. And that's going to take a file here, and then you give it the name of the format that you want to use. One thing that you'll come across fairly frequently when you're looking at other people's Nginx configuration, or if you're just kind of researching things across the web, is that you'll see the combined log format type used, but you'll never see it actually defined. And that's because it is the log format that comes prepackaged with Nginx. So if you see combined in place of main here, that's what you're actually seeing, and it's a format that's used with compatibility, and it actually maps to the same sort of format that's used inside of an Apache server. There is a definition of it inside of here, so if we search a little bit, we should be able to find that there is combined referenced somewhere. It's right here. So log format combined, this one is always there, and you'll never see this actual string really when you're looking around. Before we move on and define our own log format type, let's talk about error logging for a second. And error logging is simpler because there is no log format. You have to specify a file you want it to go to, and then you need to give it a logging level. And the way that this works, and this comes from the Nginx core module by itself, is that this level can be one of quite a few. So it can go from debug, info, notice, warn, error, critical, alert, or emerge. And this is in order of severity. So what happens is when something is actually logged, you set a log level at the moment you're logging it. And if somebody decides that they only want to have logs that are logged with the error level put to the file, then you'll never see warn, notice, info, or debug. But you will, if somebody set it to error, you will always see error and everything that is more severe. So as we move through this particular list, if you selected debug, you would see everything that is logged, whether it's in debug, notice, info, warn, error, crit, alert, or emerge. And as you move further into the severity, get towards the higher severity levels, you'll see less and less information actually show up in your log. So since this is warn, if we look at where that's at in the list again, warn is kind of middle of the road. It'll show you more information than it won't, but you will never see notice, info, or debug information in the error log as it is predefined. This is good to know if you're first working with this or you have something that you're experimenting with and you want everything that is possibly logged to kind of be shown. You can change this so that it's using a less severity. And then if one of the applications you're working with is logging at the info level, you'll actually be able to see those logs. So if we exit this file and we take a look at the existing access log that we've got, and we can use less for this, but we'll go to var log Nginx access. That was the file that was defined in the access log directive. And then if we go all the way to the bottom here, we can see that there are quite a few requests that have been made. But with the information as we see it right here, we're not getting a whole lot. We don't know exactly where the request went. For instance, these right here, these four, were from a previous video when we were demonstrating the round robin request style, but we have no idea what server they went to in this particular case or what virtual host. So this is where defining your own logging format can be really useful so that you can get logs into a shape that you know how to read and provide all the information that you really care about. So let's go ahead and do that now. We're going to define a new log format. We're going to put our new format in the nginx.conf file so that it's accessible by every one of our actual virtual hosts. And the way we do that is by putting the log format basically in the same spot that we have this one right here. I'm actually going to copy the main log format. And then what we really want to see here is going to be the additional information of the host. So this will be the host that was requested. So if this was an IP address specifically, then we will see that. If this was a domain name like we've been seeing, then we will see that at the beginning of the list. And this is just giving us a little bit of differentiating data. And we can change the name. We actually need to change the name. And we're going to set it to virtual host or vhost in this case. Now we can save this. And since this happens before we include all of our other configuration files, this log format will be available to us. So it's important that we create the format before we actually do the inclusion of everything inside the confd directory. Now we're going to go into our confd photos example, and inside of our actual server, we're going to set the access log to var log nginx access.log, and then we're going to set the actual type to be the new vhost that we had set up. Then I'm going to copy this. I'm going to save and quit. And then we're going to do that exact same thing, except for we're going to put it this time into the blog. Going to save and quit on this one, and then we'll do the same thing once again into notes. Save and quit on that. Now we will see if there's any issues. It doesn't look like there's any problem. We'll do systemctl reload nginx. And now we can make some requests to these actual hosts. So we'll do a curl header host on the notes.example.com. And then we're actually going to redirect this output because we don't really care to see it. We just actually want it to happen. And then we'll do another one. This time we'll set the host to blog.example.com. Now, if we less var log nginx access.log, and we go all the way down to the bottom, we can see that the format is very obviously different now, and it's set to show us the actual name of the host that we are requiring. So knowing the variables that we have access to from Nginx itself within the context of an HTTP server with the request as it's going through, you can utilize those when you create a custom logging format. One last thing I want to cover before we finish with this is what it looks like to utilize syslog with this, because in a lot of situations when you're actually going through and deploying Nginx, you're going to have a logging collection server of some kind set up. And on a lot of Linux distributions by default, there's going to be an rsyslog service that's already running for you. So we can connect to syslog running on the CentOS machine without needing to do anything else. But if you set this up to be a remote machine, it would work much the same. And what we're going to do is we're going to change our access log from going to the access log file to instead writing to syslog through a socket. And then syslog's going to determine where on disk it's going to write that, and that actually will change a little bit depending on what you're working with. But for right now, we're just going to care about how it works on CentOS. And we'll go into the notes here, and we have to change our access log directive here a little bit. And the way that's going to work is we're going to use syslog : and then we can give it a server attribute that's going to be Unix, and this is going to go to devlog. That's actually where the socket is going to be located. And this is kind of an odd syntax here, but there are a number of parameters that we can actually pass to syslog that are going to take this key value setup that server and Unix devlog actually utilize. The Nginx documentation provides a separate piece of documentation about logging with syslog. So if we go and we open up this particular page, we can kind of see how this is going to work out. So when we go to utilize this, there are different keys and values that we can pass to the syslog. And here's a more elongated answer here where you're just chaining them on. And notice that unlike our usual way of doing this where we have key values, they would be separated by spaces. Since this one is part of an argument that is already part of a directive, it's going to be using commas after this colon here for syslog. And then afterwards, you're still going to set the name of the access log because you're still using the access log directive itself. It's just this is a special stylized version of the first parameter that you can use. It is worth noting that, like I said, we are using the Unix socket that already exists at devlog, but if you wanted to go to a separate rsyslog server, then you could also use a server name here. So this could be a domain or an IP address. Let's go back to our actual example here. and see what happens when we save and quit. Test this. And when we reload it, we had set that up inside of the notes.example. So if we curl header host notes.example.com, and we check once again at the end of our access log, it should no longer be there. So not that the old request won't show up, but we shouldn't have a new request to notes at the very bottom. So there's still just the one to notes and then the one to blog. And this is where things get a little bit different. We have syslog running. Depending on the operating system you're running, the actual file that that's going to write to is going to be a little bit different. On CentOS, that's going to be at var log messages. And if you're on a Debian-based system, it would be in var log syslog. But let's look at the very last line of var log messages. And now we can see that we're getting this Nginx line here. Everything prior to this is extra information that comes from syslog. And then everything right here, this is our actual accessing log format that we had already predefined. So now we have it logging to our syslog. It's figuring out where the file's at. And if we wanted to, we could have this logging to a remote server. So in this video, we took the long look at logging here, how we can specify our own log format. Also knowing that we can write our logs to a syslog server, whether that be local or remote. And then air logging, we briefly touched on the fact that it's going to write to a file, it doesn't utilize a format, and it has varying levels of severity that you can utilize. But for the most part, the actual air log setup that comes by default with Nginx is going to be good enough. Welcome back to the Linux Academy Nginx Deep Dive. In this video and the next video, we're going to take a look at how we can utilize Nginx as a reverse proxy still, but utilizing it to load balance to multiple application servers. These servers can be on the same machine, like we're going to demonstrate right here, or they could be on separate machines and you could access them through IP address. But we really want to be able to balance the traffic between multiple different servers if we have scaled out horizontally in that way. And Nginx has the means to do that baked right in. To get started, we need multiple instances of the same application running. And for that, we're going to use our web client that is used in our photos.example.com. And what we're going to do is we're going to just create separate instances of the service. So we'll use CP to make some copies here. And we'll do the web client. And then with some shell expansion, we can just go from having nothing to being web client 2. And also, web client 3. This service is already made to work with a port, and by default, it's listening on port 3000. So we're going to make some modifications to this to change the port for each of these services so that we can pretend that they're completely separate servers. In reality, they're separate applications running on the same physical server, but they could be separate servers all the same. Let's first take a look at web client 2. And for this, we want to add another environment variable here. So we'll say environment port, and then we'll set this to be 3100. And we can save this file and quit. And then we'll do the exact same thing with web service 3, and we'll just give it a different number. For this one, I'm going to use 3101. 3101. Let's start and enable these services. With our extra services running, we're now ready to actually modify our configuration for photos.example.com to have this be a load balanced service. And to do that, we have to work outside of our server because what we're creating is going to be a pool of servers. And in Nginx, we're going to utilize the upstream module in order to do this. And you can see here that it's used to define a group of servers that can be referenced via proxy pass, fast CGI pass, etc., etc. And that's exactly what we need to do here. So we create something using an upstream directive outside of our server block. And then inside, there's a different type of server directive that is unique to the upstream context here that allows us to specify these different servers. And it can point to completely different servers using domain. It can use IP addresses. We can also have a server be a Unix socket in here. And then if you remember back to our proxy pass, you could do http:// and then have this extra Unix:/. So it still makes sense. We're just not going to pull the HTTP portion in here because that's really part of either the proxy pass that's going to speak that, or if we separate these out to where they're doing it with just the domain or IP address or Unix socket, then it'll still work with fast CGI pass or uWSGI pass. Let's go back and add our upstream. Whoops. So we'll say upstream, and then this is going to be called photos, and that's us naming what this particular group of servers is going to be called. And then we reference them each by doing server, and then we give it however it's going to be accessed, which for the same one we have right now on this proxy pass line, we're going to take the domain out of this, which is in this case is going to be an IP address really, and then the port, and that will be the entire thing. And instead of having this IP address and port right here, we can reference photos. And that's going to make sense. And we don't need to have a specific server that we're pointing to so that we can have multiples. Now we can come in here and change this so that we have our 3100 and our 3101. If we save this, everything we've changed right there created a server group using upstream, using the server directive inside of upstream just to define it, and then modifying our proxy pass to utilize the name of the server group instead of an individual server. Let's save and quit out of this. Make sure we didn't change anything that's going to break it. And reload Nginx. If we utilize systemctl status, and then we access web client 1 or 2 or 3, well, I guess it's just web client here, you can see any requests that were made. There was a request made at 20 hours here, but if we go and we look at web client 2, you'll see that there have been no GET requests made just yet. So what we can do is we can utilize curl and give it a header of host photos.example.com and go to localhost, and we'll do this exact same request multiple times to see what happens. It's 2 times, run this a 3rd time, and a 4th time. And now we can check out all of these. So we'll do systemctl status of web client. And we can see that we made a request at 8:23 and then also at 8:34. But if we check out client 2, you can see that we made an intermediate request there that was at 8:27. So we went from going to web client 1 to web client 2. And then in between the 27 and the 34 up here, we had a 31 right here. So you can see that what it's doing there is distributing the traffic based on whichever one was the last one. And that's because the load balancing that is done through the upstream module has different load balancing methods that you can utilize. And by default, you're going to utilize a round robin approach. So if you have 4 servers and 5 requests come in, the first one's going to go to server 1, second one to server 2, server 3 gets the 3rd one, server 4 gets the 4th one, and then you go back around, so the 5th one would go to server 1. Let's take one last look at our configuration. There's more that we can do with a load balancer if you just look at the documentation here. Unfortunately, this is one of the areas that Nginx Plus actually adds a lot of features, and those still show up in our directive listing here. So there's stuff in here that we cannot use using the open source version of Nginx right now. But just looking at what we do have, we're able to define a list of servers and then utilize that in place of a single server when we're using Nginx as a reverse proxy. In the next video, we'll take a look at how we can make modifications to our upstream context in order to manipulate how it decides to route traffic to different servers and see how the various load balancing methods work. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to continue with where we left off talking about load balancing within Nginx. And we're going to see how we can change the way that the load balancing is done. And we're going to do that mostly by looking at the docs, but it's going to be something that we can implement into our photos.example.com upstream directive that we already have. So if we head over to the documentation, you'll see that server is kind of our main thing here. And I mentioned in the previous video that we can manipulate how Nginx goes about sending traffic to the various servers. And there are two different ways. We can modify server so that it has a little bit of extra information. And then the other way is by changing the actual load balancing method that exists. And there are multiple directives in here that are related to just that. So hash is a way of determining where traffic should go based on a key that you set up. And you can make this key using some form of static information or using the variables that we've seen so far. So this key value could be something like the $request URI variable that we've seen in the past. And what that would actually do is the first time it comes through, Nginx would see that request URI and direct it to a server. And then the next time that comes through, it would try to direct it to the same server. As you can imagine, there are things you could do here that would kind of potentially ruin the load balancing aspect of things if you decided to use it this way, because you could route all of your traffic essentially to one server instead of spreading it across if you have one page that gets the majority of your traffic. But on the opposite side of that, though, you could intentionally route all of the traffic that's going to say something like your admin area to one server so that your admin requests don't degrade the performance of your actual consumer requests that are going to the public areas of your website. So hash is one of the available load balancing methods that we've got. Additionally, we have IP hash, which is going to take the first 3 octets of your IPv4 address and route those to servers. So what this means is the client IP address. So if you have a bunch of clients that are on the same network, then they could be routed to the exact same server. So once again, this is something that you could do to intentionally route some traffic to one server instead of another. But you could run into a situation where you're overloading one server. And the last one that I want to look at is going to be least con. And the way that this works, and it doesn't take any arguments, similar to how the IP hash didn't take any arguments, is it will simply route the request to the server that has the least active connections right now. In theory, this could have the same result as a round-robin approach, but depending on how long some of the connections end up lasting, it will route the traffic to the one that is currently dealing with the least amount of traffic. If we wanted to use one of these, how would we actually go about changing the load balancing method that we're using? We can make this modification by using one of the directives that we just ran into from within our upstream block. So if we wanted to use the IP hash version of this, we would simply utilize IP hash right there. And for something that has an argument like hash, you would do it like this. I would suggest putting them at the top because it doesn't really matter if it happens before the server portion, but there are some of the other directives, specifically the keep alive portions, that you need to reference what you're actually going to be using as your load balancing method before you see a keep alive directive. So I would always put the load balancing method at the very top, and then you can follow it with your server and any other configuration that you might want to work with. So just to cover that once again, the ones that we have that we can use are the default, which is if you don't specify a load balancing method, you get round robin. Otherwise, we have least connection, or IP hash, or hash. You will notice looking through the documentation that there's one called least time, and that is another load balancing method, but it is once again part of the Nginx Plus offering. And that one actually routes based on the average response time that it's getting from servers. So it's trying to route things based on the perceived performance that it's going to get based on going to a specific server. For our Photos application, we're going to continue to use the default round robin type. But the other way that we can manipulate how the server is going to go about sending traffic is by using some of the optional attributes to the server here. So in our hypothetical situation here, all of these servers are running on different machines, and maybe we know that Web Client 2 and Web Client 3 are both slower and they can handle less traffic. So in that case, we want to prioritize sending traffic to our first server, And for that, we can use the wait parameter, and we can set it to anything higher than 1, and then this server will be higher prioritized than the other servers because the default wait for any server is going to be 1. So if you have a very complicated set of things where you want to prioritize all of the servers, and you can actually rank them based on hardware specifications that you know, or just load that you expect them to be getting from maybe other sources of traffic, then you can specify wait on all of them. So this is one thing that you can do. If we look at how the actual server directive works, we can see that it has parameters. And that's, really, there's just kind of a number of them. Some of them, once again, you'll find are only usable if you're using the commercial subscription. But the ones that you'll see most often are going to be wait, max connections, which allows you to specify the maximum number of connections that you're going to send to a server from the load balancer. And this is another one that would be usable if you knew the performance characteristics of the server and you just understood that maybe it can't handle more than 100 clients or something like that. The backup sets up a server as a reserve server for only being able to receive traffic if the primary servers are all unavailable. There's also down, which just marks it as unavailable, and Nginx will not change that from not being down. And this is something you could do if you were going to do some maintenance on one of your application servers. You could come into your Nginx reverse proxy server and modify this so that you just took that one out of the load balancer manually, reloaded your configuration, and then no more new traffic would be sent to that server. But the ones that I want to talk about for the remainder of this video are going to be used in what is called passive health checking. So there's a way to do active health checking where you're continually monitoring the health of something. But the passive way of checking the health of a server would be basically waiting for something to fail. And max fails and fail timeout are two of the parameters that we can send to our servers that allow us to add passive health checking. So we're going to set both of these to max fail of 3 and fail timeout of 20 seconds. What this specific setting is going to do is going to tell Nginx that if we ever receive 3 failed requests within a 20-second period, then you should automatically mark this server as being unavailable because something's going wrong there. So that could be something going wrong in terms of it's just overloaded, or it's actually just having, some sort of catastrophic failure, but it will remove the server temporarily so that it can maybe get itself back on its feet. And the fail timeout specifically, this one kind of works in 2 ways. The 20 seconds here sets the duration that we will check to see if we get 3 failures. So if you get 2 failures in 20 seconds and then you get a third one at the 21-second mark, then it's not going to actually fail in this case. So the 20 seconds is going to be where we have to get 3 failures within a 20-second span. Then Nginx will mark this server as unavailable, which is like marking it as down, except for Nginx will put it back into the pool after 20 seconds has occurred. So this is the duration that we'll check to see if the number of failures occurs, but it's also the timeout that we're going to give it if it does have that many failures. So these 2 parameters in connection with one another are how we can add passive health checking to our servers within our load balancer. And then prioritization, we have wait, and then we also have max connections to say that we don't want to send more than, 1,000 requests to a specific server, and that way it will know that it needs to prioritize going to the next server that has the available connections. To recap what we talked about, there are 4 different ways that you can actually route traffic, and that's through load balancing methods there, and that's going to be the round robin default, IP hash, hash, and least connection. And then you can further manipulate how these individual load balancing methods are going to go about routing traffic by adding waits and max connections to set whether it should prioritize one server more than another server. And lastly, we talked about how we can add passive health checking to servers within our load balancer using the max fails and fail timeout parameters. Welcome back to the Linux Academy Nginx Deep Dive. In this section of the course, we're going to cover security and specifically dig a little bit deeper into SSL and TLS and configuring that for our servers. Up to this point, we've done kind of the bare basics that we could when working with SSL, just so that we could get traffic going over HTTPS. So in this video, what we're going to do is we're going to go through and take our example SSL setup that we have for our default configuration, and we're going to modify it to start using more and more of the specific SSL configuration options that we can use just to get a better understanding of what the SSL module provides us with. And we're going to take a look at some best practices and where to get this information and how to know what to do even if you're not a security expert. It's really hard to be, everything to all people, and security and cryptography and those sort of things are one of those areas where I think it's better to ask the experts, if you will, on things and get best practices from people who are really in the know for that than it is to just guess and do things on your own. So we're going to take a look at how Mozilla goes about deploying things using their own server-side TLS documentation. I've already mentioned it briefly, but we're going to be digging into the SSL module and using more of the directives that we are given here. And specifically, a lot of the changes we're going to be making are based off of Mozilla's server-side TLS documentation, and you can find this in the description of the video down below. And we're going to be setting up a server so that it can handle modern clients. So there's differences between what you need to set if you're working with intermediate, as they call it, so older browsers, or if you're working with only kind of cutting-edge browsers, or not even cutting-edge. IE 11 on Windows 7 is pretty old, and Firefox is currently on 59. So we're quite a ways away from things being modern. Like, these are still decently old browsers that we're working with, but we're not going to add support for older things. And there are some directives that we can leave off by not adding support for older browsers. But if you know that the clients of your server are going to need to have that support, like if you have people from Internet Explorer less than 11 visiting your site on a fairly frequent basis, you're going to want to add that support too. And this is the documentation that you can kind of look at and make some modifications based on what we're doing now to also serve those clients. To get started, we're going to cd into the etc nginx directory, and we're going to take a look at our conf.d default.conf, and this is where we had set up our automatic redirection to port 443, so we're only serving over HTTPS in this scenario. And then we had set up some ModSecurity rules also. But our SSL situation is very simple. It's just the certificate, and it's just the key that goes with that certificate. So this time around, we're going to make some modifications in order to make this perform a little bit better and also be a little bit more explicit in what we're supporting. The first thing we're going to start working with are going to be SSL sessions. So we're going to use the session timeout, and we're going to set it to 1 day. And then we're also going to use caching. So what these two things are going to provide us, and we'll go look at the documentation for these in just a second, but what these are going to provide for us are the ability to not have to renew the SSL handshake every time a client comes to us. We're gonna cache these so that we don't have to do this repetitively, because that's CPU intensive, and therefore it's going to lower the performance on our servers if we have to repetitively do the same thing over and over again, and it's taking a lot of CPU resources. So the big thing to note here is we're setting the timeout to be a day. So once somebody has actually gotten a session with us, we're going to wait a day in order to work with that. And then what we're going to do is we're going to put this into a cache that is shared. And this shared portion is important here because this means all of the Nginx worker processes will utilize the same cache. And then this is going to be for SSL. And we're going to set it to be 50 megabytes. And then the last thing we're going to do here is going to be turning off session tickets. And what are session tickets? They're if you were forcing the storage of the SSL session onto the client instead of keeping it on the server. With our configuration, we're going to try to keep everything on the server and not on the client themselves. So we're going to turn session tickets off. And if we look at the documentation for these three things, so anything that it starts with SSL_session, you'll see that we have tickets, ticket key, and then timeout and cache. So looking at timeout here, there is a default of 5 minutes, and that means after 5 minutes, the session would need to be renewed for each individual client. So by moving this up to a day, we're going to be having far fewer renewals of the session in a relatively short amount of time. If somebody has a valid session right now, it's probably okay that we don't renew their session until tomorrow. If we take a look at the SSL session cache, we can see what our actual information looked like. So shared, and then its name, and then size. So there's nothing actually special about this SSL here. We just named it that, and then we're setting the size here also. And looking at shared, you can see that 1 megabyte is roughly equivalent to 4,000 sessions. We set ours to 50 megabytes, which would give us 200,000 sessions. So the next thing we want to look at is going to be, we'll go to the top of the page here. It's going to be related to the actual ciphers that we're using and the protocol that we're using. So if we look, there is an SSL protocols. And this is one of those areas where we say SSL and TLS interchangeably. I know they're not exactly the same thing, but that's what we're going to talk about here. And there are known bugs in specific versions of SSL, and TLS 1.3 isn't quite supported just yet in the stable version here. But what this allows us to do using SSL protocols is specifically talk about which protocols we are going to use. And in our case, since we are once again only supporting modern browsers, we're going to opt to use the modern standard, which is going to be TLS version 1.2. If you were supporting older versions, then you could state that you wanted to support TLS version 1, version 1.1, and version 1.2. But in our case, once again, we're going to set it to work with only modern clients because we don't have any current traffic that's coming from older clients. So we're going to set this to be a singular value. We're going to use SSL protocols, TLS version 1.2. And the next two that we're going to talk about are going to also be related to the kind of security and cryptography side of things here. And that's going to be the ciphers. And ciphers are one of those things that, to be completely honest with you, I don't understand all of the ciphers. And when you see the entire list of ciphers that are available, it's kind of daunting. So by default, they set it to this. And this is where I'm mentioning once again that it's good to go talk to the experts and see what the experts are doing on these things. I consider Mozilla an expert as an organization anyway. If you took all of their expertise, they're really good at the web. That's what they specialize in. So it's a good idea for us to go reference what other people are doing. And this is one of those areas where the cipher suite they expect you to use is this. And I don't know colons separate the different cipher types. But I know absolutely nothing about what each individual one of these things is, but Mozilla is suggesting it. So, and this is one of those things where we're going to take a leap of faith maybe and just trust in their security experts. So we're going to copy this string. And then if we look over here at what we can do, we're going to set this as our cipher's value. So they separate it using colons also, and our server knows how to speak this. So we can come in here and set SSL ciphers to be this list. And then the other thing we want to do related to ciphers is we want to set SSL prefer server ciphers. And we're going to turn that on. And what we're doing here is, once again, we're moving all of our TLS SSL setup to the server side. And what this means is we've specified a very specific list of ciphers that we want to work with. And we can tell the server to prefer, or we can tell Nginx rather, to prefer the ones that we have specified rather than the ciphers that are preferred by the client. The last two settings that we're going to modify right now are going to be related to HSTS, which is HTTP Strict Transport Security. And also, we're going to touch on OCSP stapling. The next setting we're going to modify is related to the fact that we wanted to force traffic over HTTPS anyway for this server. And right now we're working with just our default.conf, and we haven't gone through and set up SSL for every virtual server that we've been working with just because we wanted to save time and talk about very specific things that we were doing with those virtual servers. But in the real world, as we've been doing things, you would have something set up much like we have here, where you're redirecting all the traffic over to SSL, which would mean you could say that you only want browsers to interact with your service over SSL. And that's where HSTS comes in. And this stands for HTTP Strict Transport Security. It's a way for us to tell our clients that they should only interact with us over HTTPS, and we can give them a duration of time to do that. And rather than actually working with an SSL directive like we have here, we're actually going to do this using the add header option that we had before. It's going to be the strict transport security header, and then we can give it a value of max age, and then it's 157,68000, which stands for 6 months, basically. And what this is going to tell the browser is that for the next 6 months after it gets this first request, it should not allow any request to be made to the HTTP version of the service. So it can't talk to port 80 anymore, and the browser will adhere to this and just not even try. So this is equivalent to having a 302 kind of like we had before, where it would 302 a specific URL, but that's on a per URL basis too. HSTS allows us to talk about this on a per domain basis. It's not thinking about it on just a single page. This tells the browser to redirect all traffic to HTTPS for the entire domain. As you're doing your own research about SSL and figuring out exactly how you want to modify your configurations, you're going to come across HSTS preload at some point, and that's one of those things that I'm not going to suggest using right now, but what it is, and I want you to understand what it is that you can set up your domain to be part of a preload list that the browsers hold on to. And what happens there is there will never be an HTTP request to your actual service. It will make the first request over HTTPS because the browser knows that your domain is preloaded with HSTS. The danger there is that if your website is not prepared to only handle HTTPS traffic, then you can run into issues there. So I would probably not go the preloaded route right now, but it is one thing that you can understand does exist, and some people have suggested it. You do have to set your max age to be at least a year in order to utilize that, though. The final modification to our SSL setup that I would like to talk about right here is going to be regarding OCSP stapling. And OCSP stands for Online Certificate Status Protocol. And what happens is a request is made to your server, and then a request by the client is also made to the certificate authority to validate that your certificate is still valid. So OCSP and OCSP stapling allow us to go and prefetch the validity of our own certificate and serve that to the customer or client so that they don't have to make multiple requests. And then we can also keep this for a duration of time, and that can potentially prevent us from running into issues if the OCSP requests to the actual certificate authority go down. To utilize OCSP stapling, there is a stapling directive, and we can turn this on. Unfortunately, we can't demonstrate this for our self-signed certificate because we don't have a certificate authority. We're going to still go ahead and add the SSL stapling here. Then we're going to save our configuration and quit. And we want to see what happens when we use Nginx-T. In this particular case, it can tell us that we cannot actually staple it, so it's going to ignore it. It's giving us a warning, it's not giving us an error. So this would still work, and we can still leave this configuration there, even though it's not quite going to work. So if this is something that you would do standard across a lot of different servers that you're working on, you could package this into its own separate file, and you would still be able to do that. Related to SSL stapling, there are a few other directives that you can use. Specifically, the one I want to look at is going to be the SSL stapling verify, which, when combined with the SSL trusted certificate, allows for the OCSP responses to be enabled. So we can't do this because we don't have an issuer, but if we did have an issuer, we would utilize stapling verify on, and then we could use SSL trusted certificate to point to the certificate authority's certificate so that we could make our own verifications. To cover what we've done here, we've gone through and set up some of the suggested modifications to make if you're doing server-side TLS handling. And like I said before, and kind of throughout this video really, this is an area where I would say defer to the experts on this. Utilize the understanding and expertise of other people. Most of this lesson was based off of the server-side TLS documentation provided by Mozilla, and these are required settings for Mozilla services. We should definitely be reading up and understanding some of these things, but at the end of the day, we're never going to be able to understand everything possible about security and TLS unless that's something that you really want to get into for a career. So I would encourage you to read through this documentation and see what you can find and see if there are any other particular values that you think would be useful to yourself. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at how we can secure our server from potential attacks using the ModSecurity dynamic module that we already have installed and a core set of rules for that, specifically the OWASP ModSecurity core set of rules. This particular core set of rules handles a wide variety of common attacks that you might come into contact with somebody just going at your server to see what you haven't already sort of covered. And this is another one of those areas where security is something that many people specialize in, and it's good to rely on them. And that's exactly what this OWASP ModSecurity Core Rule Set, or CRS, as we're going to kind of refer to it from now on, is good for. It's a bunch of experts come together, put together their information and the best practices that they've found, and they make it accessible to others so that the entire web can potentially be more secure through their work. So in this video, we're going to go through installing this core set of rules and utilizing it to make our blog application more secure. The first thing that we're going to do is we're going to cd into etc nginx, and then we created a ModSecurity directory. So we're going to come into here, and then the way we're actually going to interact with this rule set is by using git in order to pull down the latest version of it. And then if you need to pull updates later on, you can still use git to do that. So we're going to git clone, and this is going to be HTTPS for github.com. And then it's from Spider Labs again. And it's the OWASP modsecurity-crs.git. We want to cd into this directory. And let's kind of just look at what we have here. There's quite a few things going on, but there are going to be some example files that we run into that are the crs-setup.conf file that we have right here at the top level. Inside the rules directory, we're going to see that there is another example file for the exclusions, and then the response exclusions is also an example file. And the reason that these are .example files is so that we can create the non-example version of these, make our own modifications, and then when we go and we pull the newest source code from this repository later on, it's not going to overwrite the files that exist that we put our modifications into. So let's go ahead and copy these over. So we're going to copy our CRS setup example here, and using shell expansion, we'll just remove the example. And then we'll do the same thing for rules, and this is going to be the request 900 example. And then the same thing for the response 999. With the example files set up properly here, we're ready to actually create our own file. So if we remember back to how we set up ModSecurity in the default file, or I guess we can just take a look at it here, but that's in etc nginx conf.d default.conf. We utilized a very specific directive that was ModSecurity rules file, and we had to give it a path to a file that included all of the ModSecurity rules. So that's what we're going to do now, but we're going to do it by creating a configuration file that includes all the other files that we want to use. And what this allows us to do is we can pick and choose which rules we want to support and which ones we don't want to support for our given site. We don't actually want to put this new file in our OWASP directory, so we're going to cd back just into our etc nginx ModSecurity. And then we're going to create our file here as ModSecurity includes.conf. And there are a few things we know we want to include off the bat. Specifically, the OWASP CRS rules don't include standard configuration for ModSecurity, and they recommend that you use the ones that come with ModSecurity. And we've already been using that as our ModSecurity conf. So we can include that, and there's no need for a semicolon at the end here. And then the other one we want is going to be in our OWASP ModSecurity CRS rules, and it's going to be the crs-setup.conf file that we had created. Those are going to be the two baseline configuration files. The ModSecurity conf one is the recommended that came with ModSecurity, but it doesn't have specific use case rules. It just has kind of general settings. And then the CRS setup is going to be where we put our customizations to how the CRS as a whole works. There's not really anything in this file. We can take a look at that here in a second. And then the rest of this file is going to be individual includes lines for the rules that we want to utilize. But it's going to take us a long time to type all of those out. So let's write a bash command line that can actually go and append all of those things based on what we have in the file. And then we'll come back and we'll comment out the ones we don't want. We're going to build up a command line for loop in order to do this, but we'll do it piece by piece so that we understand what's kind of going on here. If we do ls-1, we can get single line listing for everything that's inside the OWASP rules directory. And specifically, the things we want here are going to be the things that start with response or request, and they end in a .conf. But we also don't want the example, so we're going to write kind of a regular expression that's pretty specific in order to grab all of these requests and responses. And since they're already numbered to be in order, writing this for loop, we can append them to our includes file and get them all in the same order. Let's do for f in ls-1 OWASP rules. Then we're going to pipe this into grep, and we're going to give it the capital E flag. And now we get to write a regular expression. So from the beginning of the string, we want response and request to be required. Then there's going to be a dash. Then we don't really care what happens after that until we get to a period and then a conf at the end. And we want this to be the very last thing so that we don't match the example. So we'll put a $sign there. Now we want to, we'll put this on a separate line. For each thing we get, we're going to echo include OWASP ModSecurity CRS rules, and then the name of f in there. And then we want to, it's important that we do 2 here, we want to append this to the end of the file. So that's going to go to our ModSecurity includes.conf, and then we'll end our loop. Now, if we take a look at the includes file, you can see that we have a lot of lines in here, and they go in order from 900 all the way up to 999 with all of our proper configuration files. We're going to be utilizing this with a WordPress site, and we can see that there's actually some specific WordPress exclusion rules here, and there are also Drupal rules, but we're not using Drupal, so we can comment out this line and not have to worry about it. But for right now, we're just going to run with all of these rules and see what kind of impact it has on the performance of our blog. Now that we have our ModSecurity includes file, let's open up our conf.d blog.example.com. And then right underneath this index here, doesn't really matter where we do this exactly, but we want to group them together. We're going to enable ModSecurity using ModSecurity and then just setting it to on. And then we're going to set up ModSecurity rules file. And this time around, we're going to point it to the rules file that we just created. So this will go to ModSecurity includes.conf. Let's save this. It is nice that it doesn't clutter up our server configuration, and we could create multiples of these. So since this one is WordPress related, we could have created a WordPress includes that only includes the rules we care about for WordPress related sites. It's nice to be able to separate these things out and break them up into reusable chunks as we need to. We'll save and quit. Let's make sure we didn't create any syntax errors and reload the configuration. Now to test actually using ModSecurity, what we're going to do is we're going to tail the var log Nginx ModSecurity audit, which we had created before. While tailing this log, we're going to open up a new tab. We're going to go to blog.example.com. And then while we're here, we're going to come back periodically and check our audit log. But one way we can do this is by simulating what it would look like if we were doing a cross-site scripting attack. So you'll get something like this. So it'll be a question mark param, and then as though somebody is sending in a param that is actually some JavaScript that they wanted to execute on the page. So we'll just do alert, and then close our script tag, and send that. Now, if we check our audit log, you can see that a bunch of things ended up happening. One of the things that actually did get caught was an application attack cross-site scripting issue here. So somebody was trying to do a little bit of HTML injection, which is what we were doing, and this was picked up by ModSecurity. Covering the depths of ModSecurity is well beyond the scope of this course, but this should show you how to get it up and running using some industry best practice rules through the OWASP ModSecurity core rule set. And I encourage you to read some of the files that comes with the core rule set because they're well documented. There's a lot of comments all throughout that explain kind of what's going on. So it's a good place to go read up on what is actually happening when using ModSecurity. Welcome back to the Linux Academy Nginx Deep Dive. In this video, it's going to be more of a use case situation here because you can't exactly follow along with me. This video is going to show us going through and using Let's Encrypt to set up a site that's running behind Nginx with free automated SSL certificates. There's not a requirement for you to own a domain to actually follow along with this course. That's why this is one that you might not necessarily be able to follow along with if you don't have access to a domain where you can work with some of the DNS records. But I do want to show you how this works, and I think Let's Encrypt is really, really awesome. So just to give a little bit of a backstory here, Let's Encrypt is a certificate authority that provides free SSL certificates, and they provide an API for automating the creation and renewal of those certificates. The catch with those is that they're short-term, so they only last for 90 days, and then you have to renew them, versus if you went and paid for an SSL certificate somewhere else, those would usually last a year. You could pay to have them last for longer. But at the end of the day, it kind of doesn't matter, and you can still get an A+ rating for your SSL setup using a Let's Encrypt SSL certificate. So we are going to get a certificate from Let's Encrypt for a domain that I own, and we're going to be using a tool that's provided by the EFF that is called CertBot. And this is a tool that's entirely there for automating the interactions that we're going to have with Let's Encrypt, and it actually has a plugin that lets it work directly with Nginx to create configurations for us. Before we get too far, I want to set up the DNS record for my particular server using this IP address here. So I'm going to copy this, and then I have my DNS management done through DNSimple, but I'm going to add a couple different records here, one of them being the top level A record. And then we're going to set the time to life to be really short so that we can use this within the video and not have to wait for a long time. And then we're going to add a CNAME for the www version of the site. And this is going to point directly back to itself and also have a 1 minute time to life. Now we're going to wait for that DNS to propagate, and we can come over and we actually have to install the CertBot utility. And we can do so using yum install-y. And then we're going to install CertBot itself along with CertBot's Nginx plugin by using the CertBot Nginx package. With that installed, we're going to create a very simple configuration for the website that we're working with, and the domain name that we're working with is called cord.tools. So it's an odd top-level domain, but it's one that I happen to have sitting around for a music website I was going to work on. So we're going to create this in the conf.d cord.tools.conf. And then for this, we're just going to set up a simple server that can handle listening on port 80 for our domain. And we're going to set up the location block to just serve up the standard Nginx website. We can save this configuration and quit. Kind of doesn't matter what's in there for the location block, but now what we're going to do is we're actually going to use CertBot, and we're going to tell it to use its Nginx configuration, and then we have to give it a list of domain names. It's going to be cord.tools, and then another one for www.cord.tools. There is a way to generate wildcard certificates with Let's Encrypt as of a few weeks ago, actually, and I'm not going to go through that in this video, but there is a blog post that's on the Linux Academy blog that does cover that, but it requires using some DNS verification through a different library. What this is going to do is ask us for the domain name to where it can basically send security notices and renewal notices stating that we need to renew our certificate. And I'm going to use my Linux Academy account for this. We're going to agree to the terms of service. I'm willing to share my email address. And you'll see that it's doing a few things here. And one of them is that it does a challenge. So it needs to make sure that we own the domain that we're going to. And that's why we pointed the DNS at this server first, because the Nginx module can actually go and modify the Nginx configuration to serve up a very specific challenge file that it's looking for and make sure that when that is requested, that it actually is grabbing the right thing. So it's created the certificate for us. And now it's asking us how we want to go about having our configuration. We're going to select number 2 so that it will set it to redirect to HTTPS always. And we're done. So that actually worked. And now we can go take a look at what happened to our cord.tools.conf. You can see that there's quite a lot going on in here now, and it has its own SSL setup with links to very specific PEM files that exist in the etc Let's Encrypt area. And then it also has the redirect setup. And this is different than how we did it, but it's just a little bit more explicit when it comes to the domain names that we were working with. It doesn't need to be done this way. It could just have been done the way we did it, which I think is a little bit cleaner, actually. But I do want to call your attention to the inclusion right here of the etc Let's Encrypt options SSL Nginx. And let's go take a look at this file. This is where it kind of pulled off some of the SSL configuration that it's working with. And if we recall back to looking at Mozilla's kind of recommended way of doing things, we were doing it for the modern browser types. But this configuration is handling the intermediate browser types. So that means it'll handle more protocols than what we were explicitly allowing our previous setup to work with. And it also works with more ciphers. Now we can test this to see if our domain is working. So we'll go to cord.tools, and we can see that it redirected us to HTTPS. We have the actual certificate here that's verified by Let's Encrypt, and we're now good to go. The last thing that I want to cover in this video is how we can set up our certificates to be renewed automatically and have Nginx reload once the certificates are renewed. Thankfully, since we're working with the certbot Nginx package that came through the EPEL release repository, it actually provides us with some files to do this. If we look inside of lib systemd, system, we'll find that there are 2 certbot renewal pieces. Specifically, there's a service and a timer. And the timer is going to have it go off periodically. Specifically, it's going to do this daily and make sure that it has a renewed certificate. And then if we actually look at the service itself is going to provide us with something that's going to call certbot renewal with a bunch of hooks that are going to be gathered from this configuration file. And there's one in here that's a little bit different, and that is that the post hook does not know explicitly to reload Nginx. So since we know we are using Nginx on this server, we're going to tell it to do that. And this way, when we load this service, we don't actually ever have to really worry about it not reloading Nginx when it's changed the certificate from underneath it. So we're going to go into etc sysconfig certbot. And then the one that we're really caring about here is going to be this post hook. And the example is actually pretty close to what we want. It's just doing it for Apache. So we're going to do post hook systemctl reload Nginx. And we have to make sure we put our single quotes in there too. Now we can save and quit, and we should load up the service and the timer for the certbot renew unit so that it can automatically go and fetch us our certificates in 90 days when they actually go and expire. So let's add those with systemctl start certbot renew. We'll do the same thing with enable. And then we'll do the same thing with the timer. So this video has been a short walkthrough on how to use Let's Encrypt and certbot specifically to generate some SSL certificates that we can have automatically renewed for free. And I know in the past that's been one of the big blockers for actually having everything served up through HTTPS is that you had to pay for a certificate. So Let's Encrypt offering this as a free service is really great for securing the web. And since they were introduced a few years ago, the amount of HTTPS traffic that exists in the world is a lot higher. And I would encourage you to utilize Let's Encrypt if you're not going to buy SSL certificates yourself. And even if you are, I think the way that Let's Encrypt works is probably better than most of the certificate generation tools that I've seen. Welcome back to the Linux Academy Nginx Deep Dive. In this next section, we're going to talk about ways we can modify the configuration we have for Nginx to improve the performance that we get. And one of the ways that we're going to be talking about is going to be working with content compression and decompression. A lot of the configuration that we got out of the box for Nginx is pretty good, actually, but some of the values are a little bit lower than we want them to be, or certain features aren't enabled, and that's simply because they don't know, they can't guarantee that some of the required features are going to be installed. So they don't enable them by default, and they also don't know exactly what your hardware specifications are, so they don't make those higher than they could for certain performance reasons, because they want the default install of Nginx to basically be able to run anywhere. So in this video, we're going to take a look at content compression and decompression, because if we can send compressed content to our clients, then that means that the actual amount of bandwidth that's going to be used is going to be a little bit smaller, and that's going to be good for if somebody has a data cap, it's going to be good for speed. And the majority of browsers and other clients know how to work with compressed content. So we're going to enable a few settings in this video and sort of see what it takes to work with compression. And then we're also going to go and look at what it would take to have Nginx decompress content for us in the event that we're working with a proxied service that is sending us compressed content, but we have a client that can't actually receive compressed content. To get started, we're going to need to use the gzip module from within Nginx. And there aren't that many directives here, which this is my favorite kind of module if it's small and does one thing really well. And we've already seen the gzip directive before because it exists inside of the nginx.conf file. It's just commented out. So we're going to enable this, and then we're going to modify some of the settings to make sure that we're only compressing the things we want to compress, but actually compressing more than what would be compressed by default. And this is one of the downsides to this is if you look at the gzip version here, it's simply an on and off. And that's great. So you can turn on the gzipping of responses. But if we search for gzip_types, we can see the various types that are actually going to be compressed. And that's only HTML as the content. So this means that if we have plain text that we're sending, or if there's CSS or JavaScript or anything like that, we're not going to compress any of those. So we need to modify this. Otherwise, we're not getting the full benefit that we could get out of the gzip module from Nginx. So let's get started and actually add this in. We're currently working as root, and we're going to go into etc nginx, the nginx.conf file, because we essentially want these gzip settings to be global, and then somebody can overwrite them if we have a server that has very specific uses. At the bottom of the file is where we have a commented out version of gzip.on. So we're going to enable this, but then we're additionally going to add some more things. And the first one I want to talk about, which we already did, is going to be gzip types. And this is going to take kind of a long list. So I'm going to type these out and probably speed through it, but we can sort of talk through it. And you can see these in the description down below. It's mostly going to be types of text that would be plain text if we were just editing. So this will be your resources that can actually be compressed, like CSS, JavaScript, plain text, HTML, those kind of things. And this just means that if we have a situation where the JavaScript from an application that we're proxying to, but also serving their static assets, isn't already gzipped, which it can be in some cases, then we will do that and send that over just to make it a little bit smaller. All right, there's the entire list of things that we actually want to compress here. And a couple things I want to point out is that you won't see something like an image JPEG in here because JPEGs are already compressed. We can't actually compress them anymore. So trying to gzip a JPEG wouldn't do us any good, and we would just kind of waste potential CPU cycles having Nginx attempt to do that for us. So it is good to know what can and cannot be compressed. In a lot of cases, it's going to be, like I said, just plain text that, at the end of the day would have empty spaces in it somewhere. And there's almost always something you can do if there's a space in it to actually compress it down a little bit further. These are not the only two settings that we want to enable, though. So let's go back over to the gzip documentation and take a look at what else we have. Disable, min length, and proxied are going to be kind of the couple that we're going to work with. And proxied in particular is a little bit weird, but let's go down the list here. Disabled is going to turn off the gzipping for certain situations, and this will be your older browsers. And they have a special mask that you can use here, which is just kind of a special value, because normally it takes a regular expression that is MSIE6, so Microsoft Internet Explorer, really old versions. In this particular case, we want to disable gzipping, and we're going to turn this on, so we'll use gzip disable with this specific value. Another one we're going to turn on is going to be gzip min length, and this specifies how large the content that we're about to serve needs to be before we actually even attempt to gzip, and by default, it's 20 bytes. So 20 bytes is pretty small. Gzipping 20 bytes is going to get you not a lot of benefit there. So we're going to up this number a little bit to just a kilobyte, really, to give ourselves a more reasonable thing. If we send anything over this 20 bytes, gzipping it's not a really big win. But if something's a kilobyte and we can make it a little bit smaller, maybe that's a good enough win for us. And you could even up this higher. Depending on your CPU that you have on the server that's running Nginx, gzipping a lot of content could be CPU intensive for you. So setting this to a higher number and only gzipping content that you know is kind of large or is that average for what your important content is going to be, and not wanting to necessarily compress the smaller files might be something you want to look into doing. So we're going to set disabled and min length. And then the last one we're going to talk about right here is going to be proxied. Gzip proxied is interesting because we get to specify a lot of different flags, and this can be a list of things here that maps to whether or not we want to compress the responses that we get from proxied services. And in some situations, you won't get a response from a proxied service. So if we have caching enabled and we're never actually hitting the proxied service, then that doesn't apply to this. So in those cases, it would actually still be compressed, but we would be compressing it and serving it from a cache. So the way we actually want to work with setting this up is basically if it's not coming from a cache or it's not going to be content that we are caching, then we want to gzip it because we're going to be receiving this directly from our proxied service, and we want to gzip that before we pass it over. So we're going to send it a list of expired, no cache, no store, private, and auth, because you tend not to cache auth response. So that's going to be our total list there, and that's going to sort of encompass a lot of the different types of responses we'll get from our services that are not cached. So we've talked about 3 of these new directives here with gzip disabled, gzip proxied, and gzip min length. So let's go enable these right now. I'm going to set gzip disable for MSIE6 was the special token here. Normally you would put it in a string and it would be a regular expression, but this one will work for us for right now. And then another one we're going to put is going to be gzip proxied. And this is anything related to it not being cached. So we're going to use no cache, no store, private, expired, and auth. And we also wanted to do the gzip min length. We're going to set this to a kilobyte, so just 1024. And there's only one more gzip directive that we actually want to use. And this one is a little bit weird, but the way the gzip works is the client can still explicitly request a non-gzipped version of something. And there's a directive called gzip vary that will explicitly add a header for us that is vary except encoding. And what this does is it specifies that if something is an intermediate layer that's beyond Nginx that is taking these individual responses and caching them, something like a CDN that you're using as a global cache to deliver your content, it's going to take vary except encoding. And what that's going to mean is if we get the response for the gzipped version of, say, a CSS file, that's going to be regarded as a separate file than the non-gzipped version of that exact same piece of content, so that they're both stored in the cache that's closer to the client than Nginx is. So we're going to enable this directive so that it does add this, because that's just the nice feature, especially if we have some clients that don't want the gzipped encoding, then this will still allow that content to be served from the cache. So we're going to come back and add gzip vary to on. Whoops. And that covers all of the compression side of things, but this video is about compression and decompression. And what that kind of means is that we're going to use gzip in order to actually compress the content that we're getting on the fly, but occasionally you'll run into things where you're proxying to a service that already knows how to add compression on its own, and it will compress responses, but it's going to then serve that to Nginx, and Nginx is going to know whether or not the client can or cannot work with gzip content. So in that case, if you have a client that can't work with gzip content, but you're getting a response from a proxied server that is sending you gzip content, you want to unzip it for the client. And for that, Nginx has provided a gunzip module that has only 2 directives, and the only one we want is going to be gunzip on, and this will enable Nginx to decompress content if the client requests it and the content that was sent to it happened to be compressed. We're going to set gunzip to on, and this concludes the configuration we need for our compression and decompression that's going to be shared by all of our servers. But before we conclude this video, let's go ahead and make sure we didn't create any typos. And we will reload Nginx. Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to talk about how we can adjust the performance of our server by modifying worker processes, worker connections, and then taking a look at keep alives. To get started, let's open up the nginx.conf that holds our main configuration for Nginx itself. And then up at the top, we're going to have 2 things. We're going to have worker processes, which is set to 1 currently. And then within our events context, we're going to have worker connections, which is set to 1024. And before we start modifying these, let's talk about what these do. So Nginx starts as a process that is a master process, and then it can have worker processes underneath it. And the ideal value for that is going to be the number of CPU cores that you have. You want that many worker processes. This is for a server that's, dedicated to running Nginx, really. And then worker connections is per worker process. How many connections can there be at a given time? So if we want to know the total number of connections that can be open to our server at one time, we're going to have to take worker processes and multiply that by worker connections. And finding the balance of worker processes is actually really easy, but finding the proper number of worker connections is something that unfortunately I can't give you a hard, fast number on. But let's hit these one by one now. So worker processes, if we go and we look at the core functionality of Nginx and we go to worker processes, you'll see that we can either set a number or we can set it to auto. And auto will auto-detect how many CPU cores you have and set it to that. For the most part, you're almost always going to want to use auto for this, because you're going to be deploying Nginx and you want it to be as performant as possible. You might as well use all of the CPU cores you have available to you, and auto will try its best to figure that out. And you'll know if it doesn't figure that out because you can look at the status of your overall Nginx process tree. So let's make this modification right now. We're going to change 1 to auto. And that's it. We're pretty much done configuring worker processes. We don't really have any modifications we need to make for that now. The rest of the time we're going to be spending working with worker connections and figuring out some of the hurdles there and deciding where we want to adjust that number to. If we look at the documentation for worker connections, it's going to be defaulted to 512 normally, but then the configuration that we have that was installed with Nginx set it to 1024. But these numbers are kind of low for modern servers. Nginx has existed for quite a long time now, and its goal initially was to solve the 10,000 requests per second problem, which if that was what it was created to solve over a decade ago, and computers have come kind of this far, we can assume that we can go quite a bit higher than 512, even on low-end servers. But reading through the documentation here, you'll see that this is the maximum number of simultaneous connections that you can have, and that's between you and the client, so Nginx and the client, and also between Nginx and proxied servers. So it's going in both directions there. And a problem that you can run into is that you actually exceed the number of open files that you're allowed to have. And we'll see if we run into that particular issue. But what we're going to do is we're going to take the worker connections that we have and we're going to double it. And one thing that you'll kind of find with these worker connections is it's better to have a limit that's set too high than it is to have it set that's too low. Because if we go back to our configuration, and right now, say we have one CPU and 1,024 connections, if we get a spike in requests, then after we hit the 1024 connection limit, we're just kind of losing those connections. So even if we were serving them slowly, that would be better than us not doing anything with them at all. So we can up the connection number a little bit, and then we won't be dropping connections. We'll just be underperforming, if you will, for those if the server we're working on can't actually handle it. So in our case, let's go ahead and up this. We're going to change this to 2048, which is doubling it. And with that, we're going to save. And now let's check our syntax here. Depending on the server that you're running on, you could have run into an error right there if Nginx had a soft limit that was set too low that would prevent you from actually being able to have this number of connections. And it's actually, I guess, wouldn't be an error. It would be a warning for you. But the way you could check that is by running a command as the Nginx user here for ulimit, and then you can check the hard limit, which is, in our case, would be 4,096, and then the soft limit, which is also 4,096. If you did run into that warning, which I ran into that warning on a prep server that I was using, then there's another directive that we're going to want to look at that is going to be the worker rlimit no file. I'm just going to come up here and type that in. But that's worker rlimit _ no file. And this lets you specify the number of open files that you can have. So if you know what your hard limit is, you could set this to be your hard limit. So let's go ahead and take this. And we explicitly know that our hard limit is 4,096. So in that case, we will open up our nginx.conf. And we'll set worker rfile no limit to 4,096. Unfortunately, there's not a lot more we can look at with worker connections to really know what the number is that we need to set. You're going to have to adjust this over time by monitoring logs and errors to see if you're running into things like too many open files. In that particular situation, then you're going to have to adjust some of these numbers. But then if you know that you're hitting requests that are higher than the maximum number of connections that you can handle, then it's going to be one of those situations where you maybe bump that up a little bit. Or you started at a much higher number than you think you're actually going to receive, as long as it's within the number of open connections that you can have. So working with worker connections is very much a trial and error kind of process to really fine-tune exactly what that number needs to be. But just remember that it's better to opt for a higher limit than a lower limit so that you don't drop connections. For the remainder of this video, we're going to take a look at keep alives. And what a keep alive does is it allows a single TCP connection to stay open for more than one request. And it'll stay open for a certain duration of time. And then additionally, Nginx provides us with a way to set the number of requests. And that's going to happen through keep alive requests and keep alive timeout. And if we look at this by default, keep alive timeout is set to 75 seconds. And determining exactly how long a keep alive timeout needs to be sort of depends on what you expect your clients to do. So if you have clients that are coming and then making a lot of requests in a very short amount of time, then it would make sense to have a keep alive timeout that maps to what the standard kind of time frame is that the client is actually utilizing your service. But another way of looking at this is how long does it usually take for somebody to download everything they need if they're, say, visiting a website from you? So you're serving a website, it has a bunch of resources. How long does it take for them to make requests and download everything that they need in order to see a given page? Or what is the standard duration that somebody is actually active on your website? So those are kind of statistics that you're going to want to look into as you adjust your keep alive timeout. Right now, if we take a look back in our file, there is currently a keep alive timeout set. It's set to 65 seconds, which is a little bit lower than the standard one, and that's fine. This just means, so when there's a keep alive active, then that means that TCP connection can't be recycled. So setting this kind of as low as you can, but still meeting maximum requirements for what a client is going to need is going to be really good. But the time frame is handled through the timeout. And then additionally, the other thing that we're going to run into is going to be the keep alive requests, which this is not explicitly set anywhere, but it's set to 100 right now. And this is the number of requests that can go through the exact same connection. So if a client comes to your website and you have, say, 1,000 images on your web page that all need to be loaded in from your server, then the single keep alive request isn't going to be able to handle all of those because it's only going to go to 100 and then it's going to be closed. And then that user is going to have to make a new connection, which that's the whole benefit of keep alives, is that they only have to go through the TCP handshake once and then they can make a bunch of requests after that point. So if you do know that a single client is going to make 1,000 requests very quickly, then you would probably want to up this so that you could allow them to do that. And then you could still keep the keep alive timeout relatively low if you knew it wouldn't take them that long to download everything. But then that individual client wouldn't have to make another TCP handshake, and you wouldn't be recycling these connections that the same client's going to need to make over and over again. So keep alive timeout, keep alive requests. These are the two that you're going to work with. And honestly, we're not even going to make a modification to it because keep alive timeout of 65 is a fine default. And 100 is pretty good. I don't know, besides if you're serving up a ton of images, you're probably not going to have a single client make over 100 requests in a minute. As we mentioned when we were talking about worker connections, there's more than just connections being made to clients, though. We also have connection to proxy servers. And the way that we can use keep alives with those is actually going to come through the upstream module. And the upstream module provides us with a keep alive directive. And you'll notice that this one takes a number of connections. It's not a number of requests like we saw with keep alive requests, and it's not a time like keep alive timeout. It's actually a cached pool of TCP connections that Nginx is going to keep between itself and the upstream servers. So their suggestion is to keep this low enough to where you're not maxing out all of the connections that you could possibly have. And that way, if you get a burst of traffic and you need to make a lot of requests to the proxied application very quickly, then you can still make new connections and you don't have to wait for your keep alive connections to clear up so that you can make requests through them. Since we already have a server that has some load balancing in it in the form of our photos, let's go ahead and check out the Compty photos example. And then up top here, this is where we would set our keep alive. And depending on the type of upstream that you're working with and the load balancing method rather, you're going to want to have that before the keep alive directive. So in this case, we're going to set keep alive to 32 connections at the very bottom of our context. And this is the number of cached connections it's going to keep between Nginx and the photo server itself. There are a few things that you need to make sure exist when you're using proxy pass so that these keep alives can work. And that is going to be that the HTTP version needs to be 1.1, at least 1.1 rather. And then the connection needs to be either blanked out or set to upgrade. Either of those are going to work. So you could, if you're not going to be using WebSockets, you don't need to upgrade the connection like this. And you can use an empty string there. So you would just get rid of the actual upgrade word here. But you need to do that in order to utilize keep alive connections through HTTP using proxy pass. There are other ways that we've used for reverse proxying, so reverse proxying through fastCGI and fastCGI pass and uWSGI and uWSGI pass. If we look at the upstream documentation, you'll see that it gives you more information about this, basically exactly what I just told you about the connection. But then additionally, you'll see that you can do this for fastCGI, but you'll use a different directive that's kind of similar in what it needs to do to the exact same thing as the HTTP version here. But you have to tell fastCGI to keep connections. So you would use fastCGI keep con with on. And then another thing is that sCGI and uWSGI don't have the concept of keep alive connections. So in that case, trying to set a keep alive between Nginx as the reverse proxy and the actual upstream servers that are uWSGI, it won't actually work. There's not a way to do it. To kind of recap what we're talking about here with HTTP and proxy pass, you need to upgrade the version here, or specify the version rather, to be 1.1. And then you'll want to set a connection header that is either going to be cleared out, or you can utilize upgrade. Additionally, you could explicitly say keep alive if you wanted to. So looking at worker processes through the nginx.conf, and then worker connections plus keep alives, this sort of covers all of the TCP connection modifications that we can make. Is how many connections can we have, how many processes are going to be handling those connections, and how long should a connection stay around in the form of a keep alive so that we don't have to repetitively be making the TCP handshake that just slows us down a little bit if we know that a single client needs to make a lot of requests, or if we run into the situation where we're working with an upstream server and we know that we're going to need to be making quite a few requests. Why don't we just keep some cached TCP connections open between us? Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at HTTP 2, or H2 as it's sometimes referred, as a way to boost the performance of our servers. And before we dig into how we can actually utilize and enable it for our servers, let's talk a little bit about kind of the requirements that you're going to run into with Nginx and using H2, and then also the benefits that you're going to get from using HTTP2. So benefits-wise, HTTP2 has improved encryption over HTTP 1.1. It has multiplexed streams so that you can request multiple resources using a single TCP connection at the same time. And you might have run into this before where you can only make so many TCP connections to the same server at a given point, and then any connection you try to make beyond that limit won't actually happen. The best example I can think of this is if you find yourself in a situation where you maybe bought something off of Humble Bundle and you needed to download a lot of things at the same time. You would click all the download links and it would only give you 6 of them, say, because you could only have 6 open TCP connections at the same time. That same situation happens quite a bit when we are requesting web pages, because if we take a look, and let's just inspect a page here. But what happens a lot of times is the very top of a page is going to define the various scripts. And actually, this is probably going to be an optimized example, so it's not going to run into this. Oh, no, it's here. So there are numerous JavaScript files that all need to be requested. And there's only a certain number of requests that we can make simultaneously to download these things. So we run into situations in the network where you'll see kind of a stair step of things being downloaded, which you can see right here. We have these 6 or 7 here are all requested simultaneously. And these are all images, and they're all coming from apparently some ad site. And then once those are finished, then we can kind of move on and do other things. So a best practice that used to exist if you had tons and tons of resources on a given page would be that you would divide them up into separate asset hosts that had different domains so that you could make requests to those. But with HTTP2, you don't actually have to do that. It can make multiple requests simultaneously to the same domain using a single TCP connection. So that's one of the big benefits. It's probably my favorite benefit of HTTP2 is just that it makes you not have to think about all the weird methods you could potentially make to optimize how many connections could be made for things that you're serving on your websites. But additionally, there's HTTP2 server push, which allows you to, without the client requesting it, push content to the client. And specifically what this would happen is the client makes a request to you for the HTML, and before they initiate a separate request to fetch your CSS or JavaScript, your server could initiate the push of that content to them already. And this is one of those situations where we can't utilize that just yet because it's not implemented into the version of Nginx that we're using. In fact, it just recently was put into Nginx mainline. But this is something coming in the future that we'll be able to utilize to get the content to the customer, or client rather, as quickly as we possibly can by telling them what they're going to need before they even know it. And the last benefit we're going to talk about is going to be header compression, and that is that HTTP2 allows you to take duplicate bits of headers and sort of package them into a single thing using HPACK is what it's called. But it's so that you don't have to serve over the same information over and over and over again in the form of headers. But that's enough about the benefits of HTTP2. Just know that it's an improvement over HTTP 1.1, and it actually will make websites faster. And it's based off of the Speedy or Spidey, I think it's Speedy, protocol that Google had created quite a while back. HTTP2 is the global version of that, not the Google proprietary version. So it's still in active development, but we can use it today, and Nginx is a great server to allow us to do that. So no more talking. Let's see how we can actually implement this. You'll see that there is an HTTP2 HTTP _v2 module available to you, and it has quite a few different things in here, but you'll see many of the directives in here aren't accessible to the stable version just yet. But to actually enable HTTP2, you need to be serving your content over SSL. And then what you need to do is set the HTTP2 attribute on your listen directive. So in our case, we already have something that's serving SSL here in the form of the default configuration. So if we go back and we modify confd default.conf, we go to our listen 443 SSL, we can set this to HTTP2. Additionally, we know that the Cord website that I was working on also is using SSL, so we can set HTTP2 here also. Let's save and check our configuration. It seems to be good. So we will reload. And now let's open up and go to, in my case, we can go to Cord Tools, which is serving over SSL. We'll inspect element, refresh the page, and take a look at the network here. And when we click this, you'll see that the version is set to HTTP 2.0. And we would see the same thing if we came and we grabbed the IP address, since this is what our default server is going to be serving up for us. If we paste that in here, we're going to run into issues with this potentially. We'll add the exception. And now we can see that HTTP version 2.0 is being utilized. That's all we have to do. That's the only modification that we have to make, and we can really stand on the shoulders of giants when it comes to reaping this reward that is only going to get better as they continue to further implement the HTTP2 spec as it's being worked out and as browsers utilize HTTP2 more and more. Welcome back to the Linux Academy Nginx Deep Dive. In this video, it's going to be another use case segment where we just go through and we utilize a specific tool that has been requested when we were looking at what people wanted to see in this course, and that's going to be PageSpeed by Google, or Nginx PageSpeed, as it's sometimes referred to. Really getting into the ins and outs of this particular module will be well beyond the scope of this course, but as a use case, we can go through how you would install it and get it set up, and take a look, even on a really simple web page, what the difference it can sort of make. We're going to start off by taking a look at where you would go if you wanted to find this information. You would go to developers.google.com/speed, and then you could see the actual PageSpeed modules. And then that additionally would link you to something that would be the ngxpagespeed.com, which has the documentation for how this module is going to work and how you can configure it. Specifically, we're going to want to go to the documentation and the configuration page, and this will be a good starter for how to actually go through. But the default page will show you all of the different filters that are used behind the scenes, and then you could pick and choose which ones you wanted to use once you have PageSpeed installed and ready to be worked with. When we went through setting up ModSecurity, it was a bit of a hassle. and we had to compile quite a bit, and it took a while to do. PageSpeed's not going to be that situation for us. It's not nearly as big of a deal to install. In fact, they give us a pretty neat way to install it through curling a bash script that has a bunch of different options that we can use that even make it easy for us to build it as a dynamic module. The link to exactly what I'm going to type is going to be down below, but we're going to cd into our op directory, which is where we've been putting the source code that we've been pulling down, and we're going to bash with curl -f -L little s big S, and then this is going to go to https://ngxpagespeed.com with install. And then if we just do this right now, we can say help, and it will give us a bunch of different flags that we could utilize with this. I happen to know exactly what I want to use with this, so we're going to give it a build directory of right where we're at, so this is where it's going to actually output it. And then we want to state that it's going to be a dynamic module instead of having the script actually recompile Nginx for us. And then we're going to give it an Nginx PageSpeed version of latest stable. And now it's going to do some automatic detection of things and go through and fetch the dependencies that we might need if we don't already have them installed. We didn't have libuuid installed, so it needs to do that for us. And then at the very bottom here, it's even going to give us how we would need to configure Nginx in order to do this, which this is pretty close, but not exactly what we want. We'll still copy this though, and we can make a modification to it as we go. But if we remember back to how we built the dynamic module for ModSecurity, we need to cd into the directory that we put the Nginx source code into. So that's going to be an Nginx 1.12.2 for us. And then from here, we have to run configure. And we're going to use with compat. And here's where we're going to paste in that other bit, but the path is slightly wrong because we need to go back one directory. We'll run that. And now we're ready to make just the dynamic modules. So we need to utilize the make modules task from make. And now inside of our objs or obj directory, we will have another dynamic module. So we can copy the ngx pagespeed.so, and we'll copy that into etc nginx modules, which is where we've been putting our dynamic modules. And now we have PageSpeed built and ready to be included using load module and actually be utilized. That entire process took far less time than it took for us to get ModSecurity installed, so that's quite nice. Let's cd back into etc nginx. And from here, we need to go into our nginx.conf so that we can load this module. It's going to be much the same thing as what we had right here, so I'm just going to copy these lines and change ModSecurity to be PageSpeed. And then where we have HTTP ModSecurity, I'm going to set this to be PageSpeed. And then it didn't have a module at the end, so it's just ngx PageSpeed. Let's save this configuration, and now we need to make sure it actually works. Everything is good, so before we actually utilize PageSpeed, let's go ahead and go to our blog. This will be our example application that we're going to be using. We're going to go to the network tab. We're going to disable the cache and refresh the page. So we're going to test server performance. So we want to disable the client-side caching of this. We're just going to refresh a couple times till we kind of figure out what the standard number is, which looks like it's going to be somewhere in the high 500 milliseconds. But we're going to copy what we have down here. And then inside of our configuration, we're going to just jot this down using a comment, but this will be our before. We'll paste that in. And now we can enable PageSpeed on this exact server, run the exact same sort of, not very scientific test that we've got, and just compare the numbers that we get. So to get to the configuration that we want to use, which is just going to be the default for Nginx, is go to docs on nginxpagespeed.com and then go to configuration, or there's a link down below, but we're going to copy these lines right here. And to get these in here, I'm going to set paste so I don't get any weird Vim interactions when I actually paste them in. But one thing we are going to want to change is where we're doing our caching with this line right here that needs to go into var cache Nginx PageSpeed cache. And I'm going to copy this because we want to make this directory before we actually do anything else. So let's save and quit. And we're going to make that directory. And then we're going to just make sure that Nginx owns it so we don't get into any permission errors and SE/Linux problems. Let's make sure we don't have any configuration issues, and we don't. And we can reload. We'll go back to our blog, and since we still have the caching disabled, we will reload a few times and see what we get response-wise. And some of these were significantly higher, and then some of them were quite a bit lower. So there's a little bit of variability there. Let's copy this, and we'll go take a look inside of our blog, put an after, and see what we get. So the one that we actually managed to catch, and these would have been roughly the same. It's the network performance that was probably variable, but you'll see that we actually sent over fewer bytes. So that's one of the things that PageSpeed is going to provide to us, is it rewrites the content in order to do things in order to save on bandwidth, which then in turn should save on speed and make it just faster for any client to download what we're working with because there's just less to download. And it does this through a bunch of content rewriting. And if we take a look at what we actually have here, you'll notice that this header now has a .pagespeed.ce. A bunch of other things on it. And that's because it's run through PageSpeed and it has done any sort of modifications that they see fit for this JPEG. But that's a brief overview of how to integrate PageSpeed into what you're doing. It has its own installer, which is really, really nice. And then the PageSpeed directives are not that complicated right off the bat. But if you do go to nginxpagespeed.com, you can see all of the filters that are used behind the scenes. And I encourage you to come here and read the documentation so that you can fine-tune this to exactly what you need it for on the services that you want to use it with.
You've made it to the end of the Nginx Deep Dive. I want to say thank you just for your interest in this course and for being an awesome member of the Linux Academy and Cloud Assessments community. Along the way, you might have noticed that we didn't talk about microservices or containerized Nginx, and I want to address that before you continue on. The reason we didn't talk about it is because as I was outlining the content for that, I realized that I would have only needed to teach you about the containerized software. You would have already known everything you needed to work with Nginx in that context. So you would be better served, I think, to go take some of the other courses that we offer regarding those technologies. Specifically, I would point you towards the Docker Certified Associate Prep course and the Certified Kubernetes Administrator course to learn more about how you can utilize Nginx in a microservice context, because Nginx by itself really is just a microservice. Once again, I want to say thanks, and as you've gone through this course, if there was anything in particular that you liked or didn't like, I hope that you rated it, and if you didn't, if you could take some time to go back and do so, you would really help me to improve the course and improve courses later on down the line. And regardless of whether or not you decide to rate anything, please go over to the community and share your thoughts and experiences with this course. Thanks again, and good luck learning.